Engineer, CE UGVCL, to welcome Stephen Peter, Senior Energy Specialist, ADB. I request Vaishnav Sir, GM Projects, GIPCL, to welcome Atul Kumar, Managing Director, Sabarmati Gas. I call upon Krupa Joshi, Company Secretary, GPCL, to welcome Shri P.H. Rana, Director, GPCL. I request Santosh Joshi, CEO, GSPC Pipavav, to welcome Shri Shantanu Kumar, General Manager, Oil India Limited.
I didn't heard him.
I invited it.
Yes,
Sorry.
Thank you.
Thanks. To give an inaugural speech, I invite Arun Mahesh Babu, Managing Director, Gujarat Power Corporation.
A very good morning to each and one of you present here. I take this wonderful opportunity. I hope I'm audible to the last person there, especially the backbenchers. A very good morning to all and everyone who's on the dais and off the dais. With due respects, I take this wonderful opportunity to welcome Sri Pradeep Tharakan, the person who is driving the energy portfolio from the Asian Development Bank, Manila, Philippines. I take this pleasure in welcoming you to India. I think probably back home, and also take this opportunity to welcome you to Gujarat, where you are very soon going to witness the vibrant Gujarat slowly unfolding. So welcome to Gujarat, and welcome on behalf of GPCL. I also take this opportunity to welcome our dear friend now, I can call you down under, Stephen Peters, who is also a part of the Asian Development Bank Manila, and also driving the ADB portfolio in India presently, probably South Asia and the Southeast Asia sides also. And I would also take this wonderful opportunity in welcoming our senior colleague and director of GPCL, Shri Rana Sab. You've always been a guide to the organization since time immemorial, and still very staunchly holding the torch ahead. So I welcome you to this conference, which is being organized in coordination with the Asian Development Bank. So I also take this opportunity to welcome Sri Shantanu Kumar, who's from Oil India Limited. Thanks for participating in today's conference, which is slowly going to be an eye-opener for a lot of people in India. Having said that, I'm pleased to also welcome all the wonderful speakers and participants from each and every organization who was here. I would also like to thank all the organization heads who have sent their representatives or who have been here physically. Thanks to GUVNL, which is the holding company for the energy sector in Gujarat. I also acknowledge Sen and his team who've been there from here and made it here. I'm sure Sen is always a good host and a good participant as well. Thank you to the entire team of Asian Development Bank who's been here. and taking this lead to drive the green hydrogen portfolio in Gujarat and in the India context. I also take this opportunity to welcome our partners from the KPMG group, our partners from the PwC group, and our partners from Mott McDonald, also who are from Japan. It's an esteemed pleasure to have professors from the Department of Chemical Engineering from the Indian Institute of Technology, Delhi. Last time for the Battery Energy Conference, we had a guest from Mumbai, IIT Mumbai, and it was, I'm sure, a lot of other friends were also there. I take this opportunity to welcome people who have joined us from the Aspire UK team, who have also been a part in driving the green hydrogen policy in terms of the Gujarat context. There are other participants, I'm sure, which I would not take names, but then a special mention to all the people who come from GIPCL, from GUNL, from GNFC, from other PSU groups in Gujarat, from Oil India, from Indian Oil Group, from Bharat Petroleum, from GSPC Group, and NTPC, the sectors which are working actively. I also take this opportunity to welcome each and every one of the participants from the Energy and Petrochemicals Department from Government of Gujarat and the representatives who have made it from Delhi. I'm sorry if I have not taken anybody's names. Please don't take it offending, because I'm sure all of you have been contributing well and would also continue to contribute and associate with the company of GPCL and the green hydrogen policy. For the esteemed guests who are in this hall, I would also like to draw your attention that according to the green hydrogen mission of the Government of India and the target of 5 million metric tons per annum production, Gujarat has very ambitiously aimed to contribute 20%, and we have already been in advanced stages of executing the mission. In terms of 20%, that's about 1 MMTPA is the expected contribution from the Gujarat side. GPCL being the torchbearer for the processing of the issues related to green hydrogen. And the good thing is we are also very shortly planning to come up with the policy for green hydrogen for the government of Gujarat. I'm sure other states are also doing equally good things, and the policy will always be in accordance with the Government of India Green Hydrogen Mission and based on the manufacturing policy of associated things. All of you know, this is a very catchy word, I can say, and it has been attracting people from elsewhere, from Asia, Oceania, from the Southeast Asia, from the Middle East. And latest is that the people from Europe and the West have also expressed their interest to associate with India. India ambitiously is planning to take this mission ahead, and Gujarat wishes to be the leader in this case. So, with further reference to green hydrogen mission, we expect, we hopefully expect, and I'm sure all of you here must be eagerly waiting that the price of hydrogen is one big challenge which all of us are going to face. The second is the manufacturing ecosystem and the supply chain logistics ecosystem. That would be the second challenge. That would be the issues of green hydrogen ecosystem. Having said that, we expect our partners and we expect the developers to bring the ambitious rate of $1 per kg or liter of hydrogen. Is a very ambitious case. I'm sure it will happen, but with a dedicated pace. For in that case, when even the power of solar was said that it is going to be very pricey, we started about with 16 rupees. I'm sure GUNL that time had coordinated with us. GPCL was the organization we started that first Charanka solar park under the aegis of the former Chief Minister and the present Honorable Prime Minister. And now you can see the price has come down to say less than say 2.5. And it is a reality now. Now everybody is into solar and hybrid and wind. So I'm sure even having discussed these issues, we would bring down the cost from say $24 or $15 to $1 per kg in about 5 years, 10 years, ambitiously. But let's hope it will happen. So that is the thing for today. Above all, I would ask for apologies from each one of you for getting delayed to start the conference, because we were all tied up with many other things of Vibrant Gujarat and those things. But this is a forum where I would also like to invite each and every one of you here for the upcoming Vibrant Gujarat Summit that is to be held in January. We are happy to announce that the biggest investments of Vibrant Gujarat are going to come from the green hydrogen sector. And energy portfolio is drawing the biggest investment to Gujarat this time as part of the 13th edition of the Vibrant Gujarat. I hope this association with ADB, with the other knowledge partners, with all the other consortiums, we would be able to take this ambitious plan of the visionary Prime Minister and the Chief Minister of Gujarat ahead successfully. And I take this opportunity to thank each and one of you who have made it here from each one of the organizations. Sorry if I've not taken your names personally, but in due course of the sessions, we would be catching up. We eagerly invite you to be a participant in the seminars of green hydrogen and battery energy storage, electric mobility, and evacuation and transmission systems, which would be unfolding in the month of January as part of Vibrant Gujarat. So these are precursor summits that we are taking ahead. And I'm sure all our friends from the Philippines, from Australia, from the UK, from the Netherlands, from the Norway, from Germany, and the US have eagerly expressed their desires to be a part of this Vibrant Gujarat Summit, and we are taking it happily ahead. And it gives me, pleasure in saying that GPCL is proudly coordinating on the behalf of Government of Gujarat for the energy sector. So this is a new unfolding phoenix rise for this organization, but I'm sure the phoenix has started flying, so we didn't want to let it down anymore. So I hope it will soar up high and keep flying. And thanks for this conference. Special mention to ADB for pushing us to do this conference in Gandhinagar. I'm sure we would be coming up with more conferences. So this is the third conference after the offshore wind conference that we organized here in Leela, I think about 4 months back, 4-5 months back, and a battery energy storage conference that we organized at the Taj about a month back. So this is a series of things that's happening, but these are all new technologies, these are all new areas of interest, and these are all areas of interest which works on scale of a bigger magnitude. But nevertheless, I'm sure the power generation, the power transmission, the power purchase, and the ultimate transfer to the common man and to the customer, to the citizen, will help this country achieve energy security. And with special mention in the case of Gujarat, we aim to achieve that 50% of RE efficiency in about, say, 10 to 15 years from now. I'm sure our partners from each of the organization are working together in this. GPCL is also planning something with Sabarmati Gas on a hydrogen pilot project very soon, and we are in the advanced stages of starting to execute them. So I invite each and one of you for a very positive and vibrant discussions ahead. I'm sure all the speakers are eagerly waiting for taking the stage, where we would be silent spectators and listening to you patiently. So all the best to all the speakers, and thank you for coming to Gujarat and to the Leela today, having graced our invitations. We've been so humbled by seeing the hall full, and I'll be even more humbled when you all go away with good memories after a very sumptuous lunch. Thank you. Thank you so much.
Thank you, sir. I'm pleased to invite Pradeep Tharkan, Director Energy Transition, Asian Development, to share ADB's vision for green hydrogen.
You all hear me? Okay. Good morning. Good morning, everyone. Shri Arun Mahesh Babu, MD, GPCL, my fellow panelists, and my fellow green hydrogen enthusiasts in the room. Thank you all for being here. ADB is very pleased to be able to support GPCL to organize this event today. It's a real privilege for us to be here. ADB's got a long association with the state of Gujarat. I think earlier today you were seeing some of the videos of the Charanka solar park. So one of the things we've done is to support the transmission evacuation infrastructure for that solar park. But what I wanted to do today is take a few minutes and then talk about ADB's clean energy priorities and how we see green hydrogen in that space, and then also hopefully how we might be able to support Gujarat in its very ambitious effort. Firstly, ADB is the Asia Pacific's climate finance bank. So a couple of years ago at the climate meetings in Glasgow, we announced that ADB will make available up to $100 billion in financing for the climate. And about 64% of that is going to be going to mitigation finance. Now, this is a lot of money for ADB, but it's not a lot of money considering the needs of the sector. So we want to be very strategic with the use of our resources. The second is, as you've been hearing quite a bit in the news this year, is that there's been a lot of focus on getting the multilateral development banks, such as ourselves, to do more, for us to make available more resources, for us to be perhaps less risk averse, and also for us to be able to support new emerging technologies. So we've taken these recommendations on board, which were provided by the G20. And now we are committed to deploying an additional $100 billion over the decade. What that means is, in terms of annual allocations, sustainable lending levels wise, we are going to go from about $22 billion a year to about $36 billion a year. And a substantial portion of that incremental amount is going to go to the energy sector. And we hope we will be able to deploy a lot of that in India and in states such as Gujarat. So the bottom line is we have a lot of additional resources and financing to deploy. And our work is with both the private sector and the public sector. So we work with governments, we work with state-owned enterprises in providing financing. We also work with the private sector. And in the private sector, we have a whole suite of opportunities and options. We can do equity, we can do long-term debt, both project finance, balance sheet. We can also do corporate debt, sustainability-linked loans. We can be anchor investors in IPOs. We can be anchor investors in bond issuances, especially ESG type bond issuances. So we've got the complete suite of options at our disposal. And green hydrogen is a massive priority for us. And we've been quite active in this space over the last 12 months. So in collaboration with the International Solar Alliance, ADB launched the Green Hydrogen Innovation Center, the Green Hydrogen Innovation Center, GHIC, which is an online portal to support knowledge management. So in any new area, as you will see and as you heard earlier, we need to bring together stakeholders, experts, project developers, policymakers to engage on key challenges, on issues, to share knowledge, and to learn from successes and perhaps not so great successes from across the world. So GHIC will serve to be able to do that. In addition, we've also started a series of specific technical assistance activities in states across the country. We're working with MNRE on providing technical assistance to both at the central level, but also with specific states such as Gujarat, Maharashtra, Tamil Nadu, and Andhra Pradesh. And so this event today is one of the things that we're doing. And now this is the first of many things that we hope. Our focus is on really translating high-level goals, ambition statements, policies into actionable roadmaps. And we want to focus on what we call the hard-to-abate sectors, like fertilizer, steel, refineries, shipping, port, and marine transportation. And as I mentioned earlier, Vibrant Gujarat is something that we look forward to. And we hope that we'll be able to also contribute in significant ways at the Vibrant Gujarat conference. Now, developing the green hydrogen ecosystem needs deliberate action from the governments, in particular at the central level and at the state level. I think it's important for us to keep in mind that notwithstanding all of the dialogue and the hype, and the fact that there are about 25 large green hydrogen projects that have been announced all over the world, only a handful have actually reached final investment decision. So we are at a very early stage. We need to be able to do a lot more. And Gujarat has taken several steps in this direction. As you all know, the land use policy and the allocation of large parcels of land was announced earlier this year. And we understand that the state is also going to be releasing a green hydrogen policy very soon. So the next step would be to actually prepare a detailed implementation plan, a roadmap for hydrogen hub development in the state. And what this is going to do is actually quantify domestic demand for power, for transportation, for chemical feedstocks, and then look at the domestic market, but also the export potential, and map the RE potential in the state that's available for this green hydrogen manufacture. Look at production zones, look at the demand centers, the transportation options, pricing, technology considerations, and then lay out a 5, 10, 15-year plan for rollout with associated investment numbers. That's what's going to take to actually bring all the stakeholders on a common platform and to bring to bear the resources we need to move this agenda forward. We would be pleased to work with the state government to assist in the development of such a roadmap and a hydrogen hub development subject to the government's concurrence. And let me just end by saying, in addition to green hydrogen, we are also working with the government on a range of other energy transition initiatives. We are in early discussions with Invest India and the state government to develop a low carbon development plan for the state out to 2047 and 2070. We're also in discussions with GPCL to see how we can support rooftop solar investment in the state. ADB has already approved about $500 million in low-cost financing for residential rooftop solar. And this funding is being channeled through SBI and NABARD, and it's available for state governments and distribution companies to utilize. So we hope that we'll be able to deploy some of these funds in Gujarat. We're also working on offshore wind development support. We're working with the European Union to undertake assessments of the existing supply chain and port infrastructure for offshore wind development. And we want to bring to bear lessons learned from, maturing offshore wind markets in East Asia, such as PRC, Korea, and Japan, and bring some of those lessons learned to the Indian markets as well. So again, ADB is very pleased to be here today and to support the government in developing a green hydrogen ecosystem for the state. And I wish you all the very best, and I hope you have very useful discussions and deliberations today. Thank you once again.
Thank you very much, sir. Now, as a token of gratitude, we would like to give small memento to the guest on the stage and request GPCL team to felicitate with eco-friendly certificate. I call upon Jayesh Shah to felicitate Pradeep Tharkan, Director Energy, ADB. Sri R.B. Shah to felicitate Arun Mahesh Babu, MD GPCL. Suman Kumar Goswami to felicitate Stephen Peter, Senior Energy Specialist, ADB. R.V. Patel to felicitate Atul Kumar, MD Sabarmati Gas. Inshuk Vishwas, please felicitate P.H. Rana Sahab, Director GPCL. Rajendra Mistry, CPO, to felicitate Shantanu Kumar Shahram, General Manager, Oil India Limited. Thank you very much, all the guests on the stage. Now invite stage people for the group photo. I invite for the group photo.
Yeah.
You look simple and humble, but then.
Thank you to all the distinguished guests on the stage. I kindly request you to be seated in the front so we can start the technical session.
Yeah, sure. Okay, I'll stand. Yeah. Please. No, you be seated. Don't get it pain or. Yeah, good morning, friends, delegates. We're off to a start for the technical sessions. I'll just give you a brief idea about how the technical sessions are spread over. We have actually 3 technical sessions. The first one is we have a galaxy of experienced and accomplished green energy experts who are going to speak, and many of them have his presentations. 3 of them are going to be physically present, and 2 of us are going to be joining virtually. I call upon Dr. Ramkrishna Sunday, Professor, Department of Chemical Engineering in the Institute of Technology, to grace the stage. I call upon Amit Khetkar, Principal Consultant, Mott McDonald, Japan. And also I call upon Anvesha Thakkar, Partner, Alternative Fuel and Clean Energy, KPMG, to be on the stage. Yeah, and also I call upon Subdeep Sen, General Manager, Geominal, to also be on the stage for the speaker session. I would, and I have to invite, I would like to call upon Mamta Bhavsar, GPCL, to give a token of appreciation to Dr. Ramkrishna Sonde. Virtual. I call upon Kuldeep Jhala, Energy and Petrochemical Department, to give a memento to Shri Amit Khetkar, Principal Consultant, Mott McDonald, Japan. And I call upon Kinna Katara to present the memento to Anvesha Thakkar, Partner, Alternative Fuel and Clean Energy, KPMG. And lastly, I call upon to give a token of appreciation to Mr. Subdeep Sen, Juvenile. Rajendra Mistry, you can do the honors. Thank you. Now, Steve, I'll hand over the mic to you to give a short introduction of the esteemed panelists and the experts who are under there. Yeah, please. The stage is yours.
Thank you.
Yeah.
Thank you and namaskar, everybody. Welcome to the technical portion of this event. We're going to move very quickly and there's a lot of content. So if you wanted to have a 101 for hydrogen and hydrogen development, the next hour is going to be it. So I'm going to be very quick and I'm going to call upon my friend, Dr. Ramakrishnan Sonde from IIT Delhi. And sir, the floor is yours.
Good morning. Am I audible? Oh, yes, I think I'm audible. I normally don't need even. Yes, let me begin the presentation. Thank you very much for inviting both GPCL as well as EDB and KPMG to this particular function, to this particular program on hydrogen as the new energy tool for transition. I know that, there's a huge amount of buzz around hydrogen, new kid on the block, and very often, we are all masquerading as experts. But I must confess that I'm also a beginner in this particular field, but would like to narrate you in next 10 minutes about the journey and the aspect that we are actually working in the form of a Hydrogen Valley Incubation Cluster. Okay, this is a cluster that we are developing in one of the IITs, IIT Delhi and IIT Jodhpur, with a large amount of participation from the industry as a microcosm of what is going to happen in the future. Because Hydrogen Valley has got many connotations, and I would like to feel that India must not lose this opportunity. I think we have been all the time saying that we miss many opportunities, but I think hydrogen is a $1 trillion business opportunity, and I feel we need to really catch and lead the world in terms of what is that we need to be doing in hydrogen. So in order to ensure that, I just thought let me give you a little overview on what is the proposed hydrogen flow in the system. So if you assume that by 2015 that's going to become around $27 trillion economy, and we'll be needing about 30,000 terawatt hours of energy, energy will be flowing in two forms in this country. One, of course, the wired power, and second one is hydrogen as a both fuel and the raw material into the system. And therefore, what I feel that this country will have this hydrogen as a major energy carrier, because I must focus it that hydrogen is not a primary energy resource, it's an energy carrier. So that concept is very important. So we feel, this is a modeling that we have done in IIT Delhi, that there'll be 5 sources: solar, wind, fossil, and of course water as a source of hydrogen. And these things, of course, I want to add the nuclear also to this, because nuclear will also as a SMR, small modular reactors, and generate hydrogen out of it. So our own take is that you will have this hydrogen coming from renewable energy, of course, solar and PV, where you convert part of it into the electricity and feed it to the grid, and part of it you convert that into hydrogen using the water electrolysis. Then hydrogen can also come from the fossil fuel, the nuclear, hydro, and coal, because you must understand that when you actually look at India's total energy requirement, you will realize that renewable energy will not only be able to meet the entire requirement of a carbon-free energy or a net zero pathway by 2050. India would definitely need its own fossil source, and fossil will not be used for electricity generation, but fossil will be reinventing itself as a hydrogen generator with a CCUS, that's a carbon capture, and I'm not going to touch at that particular aspect. So this is one way hydrogen will present itself, and that total hydrogen requirement by 2050 will be in the order of about 350 million tons. So what our Honorable Prime Minister has stated, about 5 million tons by 5 years from now, by 2030, will now has to expand itself to about 250 million tons. If I assume that by 2050, 50% of the energy will come from hydrogen, 50% of the energy will be flowing in the form of electricity. There's also another part, which is biomass or a distributed renewable energy. So I really feel that for this country, we should have a centralized energy generation as well as energy generation coming from the biomass, biowaste, because they are an important source of hydrocarbon or carbohydrates. And therefore, these are the two sources. So we'll have 5 sources of energy, 2 carriers, both non-carbon or carbon-free carriers, and we'll feed it to the industry, electricity, transport, agricultural, buildings, and water and wastewater. So, so what I feel is that from a current devices of all those power plants and fossil boilers and fossil running transport to a fossil-based chemical complexes and steel mills and fertilizer plants and refineries, and then fossil-based agriculture where you use ammonia from a fossil to run your pesticides and fertilizers and energy. I think what will happen is we are going to transform in next 3 decades, very challenging, through a completely green energy where you will have hydrogen boilers, you've got hydrogen transport, you've got a decarbonized hydrogen-based steel and cement, and you will have a green agriculture. So how can we quickly ramp up? Because to go from a current 5 million tons to 250 million tons, my dear friends, is an enormous task. I mean, it's a huge challenge. An enormous amount of funds and technologies and innovations have to happen. And end of the day, we would like to get the cost to be under about 100 rupees or $1 per kg. And therefore, it will require a multiple way. So I do not really color hydrogen as a green hydrogen, blue hydrogen. Sorry, I think I may be creating little provocative statements here, but that's for a separate discussion. Why hydrogen by itself is becoming a green? Because hydrogen, when they are using it in the form of a fuel cells, the efficiency of hydrogen, even if it comes from a fossil, can generate or can reduce the carbon dioxide emission by almost 30 to 40%. That means for a per kilowatt hour of energy that is coming in the room, if today you are emitting about 1.8 tons of carbon dioxide at the source, we can reduce it to about 1.2 tons per kilowatt hour is the aspect of it. Now, what I'm going to do in next 5 minutes is this Hydrogen Valley Incubation Center. So what we thought is that look at how do you really develop this. There seems to be a lot of disjointed efforts which are taking place in this country. So what is decided by the Government of India and Department of Science and Technology with MNRE is let us build this Hydrogen Valley Incubation Cluster Program. So my dear friends, I'm going to spend some time with you to understand how we are evolving this particular system. I'm leading these efforts from IIT Delhi side. We, academia, industry, research institution, you can see we have got about 8 industries which have come on board. We have got about 6 academic institutions which have come, and we've got 3 research institutions who have come together for building a platform. So we're building a complete platform from power generation to water electrolysis to hydrogen to ammonia to the end use at 300 tons per annum. You may say 300 tons per annum is so small, but I still feel that this is a microcosm of what is going to be doing as a hydrogen. So if Gujarat wants to set up this kind of a program, I would like to invite you that come to us, look at the way that we are developing this, because this particular thing can be really, really scaled up or proliferated across the country. The salient feature here is, because today if the technologies are new, we are talking about a VGF as one of the major, and VGF as the OPEX. I'll come to that OPEX-based VGF. Other incentives are available. There are a huge amount of innovations, and all 3 aspects, generation, storage, transport applications, are integrated under one roof, so that you can come, see, touch, feel, smell how exactly this whole hydrogen economy gets evolved. So the objective of this is diversity in hydrogen use. So in our plan, in this cluster HVIC in IIT Jodhpur, we have got 3 different uses. One is for mobility. We are using internal combustion engine. There are OEMs we are working with, and that OEM is, in this case, one of the major OEM of this country. We have developed a internal combustion engine base. I'm working also on a fuel cell based system. They will be taking offtake of about 38 tons per annum. Hydrogen in the blending, which is going to be 10 tons per annum. I mean, Sabarmati Gas can also examine whether we can do that. And then we are converting it to ammonia synthesis. I'll tell you about something about ammonia synthesis. We are developing a very small skid-mounted ammonia-based system using our own catalyst and our own process design. Diversity in hydrogen production, we are using water electrolysis, we are using biomass. Deployment of huge amount of technical innovations. My dear friends, this is not time. As I said, that's a small scale ammonia plant, indigenous water electricity. We are working with BRC, fuel cell based CHPC, and hydrogen based ammonia plant. And there's a world class state-of-the-art testing facility and standardized facility we are building. So this is the main object of the program. So this particular program has got 16 hectares of land where we are integrating all these things. You can see on the right side a very beautiful system of a coupling a water electrolyzer with a PV plant. Rajasthan government has been kind enough to give us a banking power where we can put a 10 megawatt of PV plant, which can generate 300 tons per annum on a continuous basis. And that is where we have developed a very, very important water electron, because we talk all the time about water electrolyzers. But I want to tell you, my dear friends, it's important that we look at this whole aspects of integration, because the DC-DC converter, and again, I'm tempted, coming from a technology side, I feel that I must be talking to you, but it's a very important MOSFET and IGBT-based system, which is giving me about 98%. So that complete analysis that we have done is to ensure that whatever solar power that we are getting it, we are able to almost get 98% of that power going in the water electrolyzers, and that's the way that we have designed the system. We are also developing a biomass-based gasification. It's a state-of-the-art system where you're using a plasma and oxy-blown steam gasification, where all the pyrolyzed biomass coming from lignin and cellulose and hemicellulose is converted into hydrogen. So our conversion is about 1 kg of hydrogen for every 12 kg. This is a world standard, because normally if you look at it, about 17 kg of biomass is required for 1 kg of hydrogen. Our technology, we are able to get 12 kg, so you can understand if you are able to source a biomass as a agri residue, one of the lowest form, which is not coming in conflict with food and fodder, you will realize that even if I get it at the 1 rupee, that particular biomass, 12 rupees is just the cost of the raw material, and therefore going up to 100 rupees is eminently possible. And then we are using storage, high pressure storage, as well as we are developing a ammonia production. One of the best innovative system. We are developing our own catalyst. We have developed our own reactor. It's a new reactor. We are not using a Haber-Bosch kind of a reactor, but a very, very different concept, which is known as isothermal reactor, and using a thermosiphon system to build a 5 TPD plant. Yeah. 2 minutes, yeah. So budget is about 158 crores for this 300 tons per annum. And we have done the cost calculations. So the cost of hydrogen that we are getting is about 270 rupees per kg. It's a very, very attractive cost. For the reason we are putting it in Jodhpur, where the solar radiation is of the order of 2,200 kilowatt hours per kilowatt. Per kilowatt of install. Number 2, we have got a complete banking of the power, and number 3, we have got the best of the power electronics, which can integrate the system, and therefore we are getting about 270 rupees. There are many aspects which I'm just not going in. Now coming to the user side, we have identified a pyramid of hydrogen applications. So from ammonia to mobility, to distribution, to, you can see those 4 sectors. We have identified about 8 industries and 1 industrial consortium to work on this particular system. And there are options, how much will go to mobility, how much will go for blending. And one important thing is, we always talk about water electrolyzer, but pressurization dispensation is most important. Today, if India has to develop a technology, I was talking to BHAL, I said, don't go just after on the crowd that you want to develop electrolyzer. What is most important is the dispensation. Today, cost of hydrogen is 270 rupees, but cost of the hydrogen at the dispensation point is 1,000 rupees 1020 rupees. So 800 rupees gets added in this particular system, and India has to really focus on these aspects. Fuel cell based system is very important. We are developing a methanol based fuel system where hydrogen will be converted to methanol or ammonia, and where, again, I don't have a time, but you can look at it. That's the best way, rather than carrying hydrogen, carry as a liquid clean fuel or a less carbon intensive fuel, and you can see those numbers where it becomes very important. So finally, last thing, my dear friends, we have got a lot of things on the table. I think this kind of a consortium, and I'm making this efforts to come here, is to communicate that we need to collaborate. Whatever we are doing today, as I mentioned in my 300 tons per annum, is just one of the current state of the TRL level 7. How can I push it to TRL level 9? So that's the effort that we are doing in that 158 crores, where I'm getting about 38 crores as a grant in aid by the government of India. That's a project where all of us are doing known technology but integrating it. But back end, there's a huge amount of research and development which is required. And that's where, concluding thoughts, they need to build several hydrogen valleys, R&D at many levels, industrial collaborations, sovereign funding as a grant, and setting up of clusters for manufacturing devices and components. Thank you very much. Sorry for taking a lot of time.
Thank you, sir.
Gotta love Professor's energy. Next, we're going to have an intervention by Subhadeep Sen, who's the General Manager of Gujarat Urja Vikas Nigam Limited, which is one of the subsidiaries of GPCL. So, floor is yours.
2 minutes is the time. Thank you, Mr. Stephen. My time starts now.
Yeah.
Good morning, all of you. It's a privilege to be here. Thank you, GPCL, and to be here on this stage. It's an honor. Thanks. I come here to represent Gujarat Power Sector, the holding company GUVNL. My honorable MD and my honorable chairperson, ma'am, could not attend due to their occupations in other meetings. In GUVNL, we are the power sector. I will draw a beautiful analogy to explain you how we are placed. Look at this plant. The bottom portion is brown, and we are where we were 5 years ago. And now we want to grow this plant and become green. So it's a long journey which we started almost 12 years back with, as Mahesh Babu sir said, with 15 rupee tie-up for solar. And since then, it has been a beautiful journey led by our honorable CM and now honorable PM sir. So carrying forward his dreams, carrying forward the dreams of Gujarat, we are here to go for the transition which we aim. Today, we have reached a stage where we are already visible in the entire country. We are second or third in terms of renewable. We have almost achieved the big renewable targets of the Regulatory Commission. And for your kind information, we are about to go and achieve another 100 gigawatt by 2030. It's a very, very ambitious target, but we expect with all stakeholders, with the government support, with the Ministry of Power support, and untiring efforts of organizations like GPCL and Energy Department, we would be able to achieve this. With this, I think it has been a beautiful journey so far. We have been going very, you can say, aggressive on the Kaura Park. It's the largest hybrid park coming up. You must be aware of the thing. GPCL has been playing a very, very important role in this big project, which is of national pride. And the stakeholders who have been given land have been actually doing a great thing. And we are sure in next 5 years' time, we will see Khavda taking off in a very, very big way. Thank you. Thank you, all of you. We would love to get associated with ADB, World Bank, Zyka to take us forward in this journey. Thank you so much. One apology, I would excuse myself from this panel discussion, and I need to go to Energy Department. We have a meeting scheduled with Zyka team today. Thank you so much. Thank you.
So you can tell we're at the start of the journey and this talk about how much hydrogen costs and where it's going to be. But I just want to remind you that solar energy was extremely expensive quite recently. Next, we're going to have a presentation by Mott, and the presentation by Mott will take 2 parts. Do we have our colleague who is online? I'd like to introduce both the Mott speakers now, if I could. Mr. Ahmed Halima from Mott, who will be joining us virtually, and Mr. Amit Kedkar from Mott from Japan. Amit, could I ask you to come up here so you can follow on from Ahmed? Okay, gentlemen, the floors are yours.
Hello, everyone. Can you see my screen? Can you see my screen now? Can you hear me? Hello? Hello?
Hello, Hamid. Can you talk?
Yep. Can you hear me?
Yeah, we can hear you.
Wonderful. Can you see my screen as well? And let's kickstart this discussion. I think we're quite limited for time and I've been given 5 minutes. So allow me to first introduce myself. My name is Dr. Ahmed Halima. I'm based in Sydney, Australia. And I work with Amit Kidkar, who is based in Japan. I'm leading up the hydrogen and future fuels at Mott MacDonald, and we're a global engineering firm that it focuses on facilitating energy and hydrogen capabilities for major infrastructure for the industry. So quite aware that India is sort of starting in this new journey for hydrogen economy. So I thought maybe I would share some insights from international insights around the hydrogen economy, and particularly for an example for Australia.
Can you share your presentation? Can you share your presentation?
All right.
Beautiful picture on it. That's it. Yep, we can say it now.
Yeah, we can see.
Wonderful. So just to talk about hydrogen today, hydrogen is not a new part of our energy system or industry. In fact, actually, we have current hydrogen uses globally, and that hydrogen use is generated from mostly fossil fuels and directed at different uses in industry and transport. So what you see here is potentially a bit of a diagram that shows the various uses of hydrogen. So, and the demand for hydrogen currently is kind of co-located and facilitated to industry and uses in minor uses in transport. So the energy transition puts forward a potential opportunity to grow the hydrogen industry in globally, and particularly as well for India, having and knowing that the capability in India around manufacturing industry is quite substantial globally. From global examples, we are seeing that the development of hydrogen economy or the hydrogen energy transition is benefiting across different energy and industrial transition or capability. For example, if you were to look at the various uses of green hydrogen and ammonia or transport feedstock for industry and power generation, you would look at an integrated system. So as is the case from, for example, developments here in Australia and the US and the UK, we're seeing that hydrogen developments come together with renewable energy zone development. Hydrogen hubs are facilitating new industrial precincts. And where you would look at developing the hydrogen economy locally is to there's a significant opportunity to co-locate the hydrogen development with developments in renewables and transitioning industries or decarbonizing industries. So as much as the export potential that comes from transitioning to the hydrogen industry, where you bring various clean fuels, decarbonizing existing industries, and also do not forget the capability of India in manufacturing, as we all know. So such an example from Australia, but besides other countries, Australia in the Asia Pacific is sort of well positioned for producing hydrogen or producing different fuels in Australia and exporting that internationally. So there's a primary objective of evaluating the system transition to hydrogen at the scale of India and internationally, where India will play a role to transition neighboring or international countries. And that role depends on the ability to use the energy transition and the system itself to facilitate optimal use of electrolyzers connected to renewables or the grid, as well as looking at how to balance the system from the available renewable energy and the cost of renewable energy to facilitate India and put India on this map for both exporting hydrogen and associated technologies. So there's a significant role that policy would play in this. And I think the journey that India would be going through now is very similar to the journey that Australia has been going through in the past 6 years or so. And I'm looking forward to follow that journey ongoing. And I'm now going to hand over to my colleague, Amit, so he can carry the discussion forward. Thank you very much. Nice to meet you all.
Thank you, Ahmed. Next. Second. Yeah, that one.
Good morning, all of.
Can you hear me? Yeah. Good morning, all of you. My name is Amit Kelkar. I'm from Mott McDonald Japan office, working as a principal hydrogen consultant there and supporting mostly on hydrogen and future fuel projects in Asia Pacific region. I will not take much time, just 10 minutes only. So mostly I will cover like today's agenda, like our capabilities and what we do, and like I would like to discuss more on like offshore, like wind feasibilities, like hydrogen production from offshore wind, and our experience in this and what we learned from our past projects, and moving forward, what could be the applicable to India. So basically, I'm working in this field from last 10 years. Don't go on my hairs. Actually, I just colored yesterday, so I'm an experienced guy. So don't worry about this. So I'm talking based on our own experience and individual experience. So we are already developing ourselves, and we are already supporting in hub developments and hydrogen sectors, grid connection studies, and already like we have already delivered the feasibility projects. So more than 70 projects we have as of now we have completed in last 3 years. Basically, if you look at these are our like key highlights of the projects. We can discuss in detail like whenever we will talk after this session. So I'm happy to discuss with all of you. Today I would like to cover for this session. There are 2 projects. One is like a Northeast 2 project. This is in Netherlands, where the consortium like you can see Shell and the other Equinor. They are looking for 10 gigawatt hydrogen wind installation. They are looking for 0.75 to 1 million ton of hydrogen production. They have already identified the location. They have already identified the natural gas pipelines which they can repurpose for the hydrogen supply. The 5 industrial the clusters are will get established to supply the hydrogen for steel and cement industries. Likewise, another project is a North Sea Wind Hub project. This is also the same kind of project, but they are planning for very high scale compared to Northeast 2. They are looking for 150 gigawatt in 2050. But this is more on like a hub and spoke concept. And the reason why I'm talking in those 2 projects are we are involved in the conceptual designs, the risk analysis, the cost analysis, which are helpful for making this project for the FID level. So based on those learnings, I would like to talk on like, excuse me, remote is not, okay. So to consider those project incentives are important, and I think like these are the 11 key incentives which are in Europe, which are helpful to consider such kind of projects. And likewise, each country they have their own incentives, and that is also coming up now, gearing up, which is useful to support such kind of projects. If you talk about like offshore, like considering the Europe wind speed and the hollow coastline, there is this is a kind of like a driving force. Also, there is a like interconnecting agreement declaration, EU declaration, where the 9 countries can interconnect their wind energies. That is also pushing up hard for the offshore wind projects. And if in terms of technical findings, we have designed like this. This is a view for so we can see here we have designed this hub like a 3 layers. Top level is electrolyzer, middle level is for cooling systems, and the down level is for power transmission related thing. So for roughly one hub is one module is almost like a 500 megawatt. So this is the conceptual design what we have provided. What we have found from the economic analysis is like onshore or offshore, the module cost will remain same. But however, when we talk about like whether you want to make it as a the grid electricity production or hydrogen supply, then the cost makes more changes. And so as you can understand, these are big projects that in terms of economical, but they also create a socio-economic impact. So from this project, we can see almost like a 15,000 to 49,000 when it project in the design phase, the jobs are coming up. Or if you talk about the maintenance phase, almost like you can see the 2,000 local jobs are coming up. So this is also one of the things we should consider when we talk about the hub developments. And if I talk about like what we learn, I think the main key thing is integration of the local supply chains. The power to gas, I think it's whether we should go for onshore or offshore. It all depends on whether you want to transmit the electrons or you want to transfer the molecule. Also, it depends on the local rules and regulation. It also depends on the sites, how much the sites are available. And also the local supply chains and the RE development, because most of the cost related to such projects are 50% capex or 50 to 60% capex is for wind investments. So this should be considered while developing such projects. And if I talk about like for India, like what we can see, like we already have the potential of 140 gigawatt, and there is like export market is developing, but rather than considering the export market, we do have potential to use it for green hydrogen for local decarbonization sectors, where we have like a 40% emission from hard to abate sectors. But the key challenges still remain like infrastructure developments and the local government policies and support. And I believe like if moving forward, if I will see those projects, like based on my understanding, I will take 3 takeaways. One is like we should have the integrated approach. The local kind of like a joint venture should be there rather than one is developing the whole project. Other thing is like modular approach, like rather than just going for higher scale, it should be stepwise approach, so that we will learn from those approach and we will make it implementation kind of learning curve, so that we can make it in a better way, we can position ourselves in a better way for the next phase. And the last thing I consider is like a local production. It's always better to have the local production rather than talking about export from the import from the other countries. Yeah, so thank you all.
So we've heard the technical side from Mott and a little bit about the development side. Now we're going to move to KPMG, and we've got Mr. James Mackay from KPMG UK online. James, can you hear us?
I can indeed. Can you hear me?
We can. Can we see your presentation, sir?
You can indeed. Let me just share my screen with you for one moment.
And whilst you're doing that, after the presentation, and Ma'am Invasha Taka will be following on in person. Sorry.
Brilliant. Can you see my screen?
Okay.
Yeah.
Off you go, James.
Brilliant. Thank you. So I'm just going to start with a quick introduction. So I'm James Mackay. I'm the Managing Director for Energy Strategy here in the UK team. And I also have the grand title of being the chair of KPMG's Global Hydrogen Network, which is essentially an internal network, which is just designed to bring together our global experts in this area. And we now have, I think it's actually 39 member firms. This might be a slightly old slide, as part of that network, including India and Invasha, who will speak shortly after me. I always like to start with the very simple basics on hydrogen, just to reiterate that hydrogen is the most abundant element in the universe. However, it does need to be produced. It's not a primary energy source. It is versatile, which makes it a key asset in the energy transition. and it's clean, which makes it hugely investable in the transition to net zero. I think the most important element that we've already touched upon today is the importance that hydrogen plays as an energy carrier. So I'm always very keen to point out to my team when they come in from new sectors that energy is only valuable if you provide it in a form and at a time where people demand it. And if you don't, then it loses its value significantly. So hydrogen's ability to be an energy carrier and be able to transport and store molecules at scale and over time is going to become incredibly valuable in the energy transition. Just here in the UK, we spend currently over £3 billion a year on curtailment charges for offshore wind. So we've developed a huge amount of offshore wind in the last 10 years, but it's often produced at a time where there's not a huge demand for it. And we have to pay those wind farms under the current subsidy mechanisms to turn off. And that's a huge waste of energy, but a huge opportunity for green hydrogen. So just because hydrogen is a versatile commodity doesn't mean that it necessarily should be used everywhere. So I think the best place to start is with a simple graphic of where hydrogen should be used, particularly in these early stages where it's such a valuable commodity as the industry scales over time. So obviously hydrogen can be used as a fuel for transport and power. It can be used for heat for industry and buildings, and it can be used and is used as a feedstock in both chemicals and the manufacturing of products. There's some clear cases where we probably shouldn't use hydrogen either now or in the future, and that's in areas such as passenger vehicles, short-haul aviation, and in most geographies, low-temperature heat to heat residentials and buildings. There may be some niche cases to do that internationally, depending on legacy and existing gas infrastructure. I think the huge value that hydrogen will begin to play over time is to provide resilience and backup power to those systems which are going to be increasingly electrified. I think electrification is viewed as the predominant source for decarbonisation through to the transition for net zero, but given the nature of the intermittency, hydrogen will play a key role as a backup energy provider. So just having a look, I've been tasked with giving a bit of an international perspective and macroeconomy view. So if you look at some of the latest forecasts on where hydrogen demand will move between now and 2050, as we sit here today, we produce roughly 90 million tonnes of hydrogen per annum, and the large majority of this is generated for chemicals and refineries. I think over time, you'll start to see blending playing a particular role, and there's examples of that here in the UK already, and that reflects some of the lack of progress that we've made downstream in terms of being able to convert some use cases downstream to hydrogen. So the ability to blend hydrogen up to 20% in existing networks here in the UK is critically important. I think over time, you'll see, as I referenced on the earlier slide, the growth of hydrogen in electricity generation and heavy goods vehicles in transport. You'll also see it deployed likely in shipping. In terms of global hydrogen targets, you see these emerge internationally now throughout the world. So Europe has a 20 million tonne target by 2030, some of which is to be imported, some of which will be produced domestically. You also see very ambitious targets in Asia with Japan and Korea, and in North America with Canada, and obviously the US. The introduction of the Inflation Reduction Act has been what I'd call a game changer. We also see a huge amount of ambition from the likes of South America in the Middle East in terms of their ambitions of producing hydrogen, particularly green hydrogen. But there's still questions outstanding on how you can ship large volumes of hydrogen across continents, across oceans at scale, and making it commercial. So just a quick summary in terms of what some of the subsidy mechanisms and the competition to develop supply chains look like. So the UK made a head start on this back in 2019 with the introduction of net zero. I think the introduction of net zero as a concept has basically been a game changer for both hydrogen and CCUS, because there's nowhere for the harder to abate sectors to hide. And the predominant solution in those sectors will be hydrogen and CCUS. So we've seen a huge amount of progress since the introduction of that net zero target. We've also seen Europe develop their own funding pots under the REPowerEU initiative and the new introduction of the EU Hydrogen Bank recently, which competitive processes have already begun for funding from. In the US, and we've seen this palpably with our clients here in the UK, since the introduction of the IRA and the generous tax subsidies that come with that for both green hydrogen and carbon sequestration, a lot of our clients' attention have pivoted to potential production assets in the US. And I think given that how generous that subsidy is, irrespective of the progress around the policy and regulatory reform in the likes of EU and UK, I think the short-term attention will naturally pivot to the US for private sector companies to capture those subsidies. So I'm also, in addition to giving that global perspective, I was asked to spend a minute or two on what's happening in the UK. So the UK have a net zero target by 2050 versus 1990 levels of emissions. To date, we've made a lot of progress by decarbonising our electricity sector through offshore wind, but we currently remain off track for delivering our legally binding carbon budgets in the mid-2030s, 2040s and 2050s. So more work needs to be done there from a policy perspective. However, since the Prime Minister's 10-point plan for a green industrial revolution back in 2020, there's been a huge swathe of policies and strategies being implemented by the UK government, which will progress the hydrogen industry over time. They almost come out on a monthly basis at the minute. So as a consultant to keep up to date with all of this, it's incredibly taxing, but it's a lot of fun. So I just want to share a little bit of a high-level pathway on what the journey to net zero would look like through the lens of hydrogen for the UK. So as I mentioned, the UK hydrogen policy was released in 2021. They've set ambitious targets for 10 gigawatts of hydrogen production by 2030. And we should start seeing some of these projects reach final investment decision over the coming months and years as the government enter bilateral subsidies discussions with some of the more advanced projects. And then over time, it's about scaling the delivery of those abatement technologies and holding more regular competitive subsidy auctions akin to offshore wind here in the UK over the last 10 years, but for hydrogen. And I think the other key element of this, of hydrogen production in the UK, is the development of industrial hubs. So there are currently 8 industrial clusters in the UK, which will support both blue and green hydrogen production. And within these clusters, this is where you see the large majority of concentrated industry and emissions. So given the lack of a midstream for hydrogen at the moment, it's quite likely that you see a lot of the emergent production capacity emerge within some of these hotspots within proximity to some of the early stage demand in the chemicals and feedstock industry. The UK have selected 2 track 1 clusters, which will receive up to £20 billion worth of funding between now and 2030, with the view to capturing 20 to 30 megatons of CO2 per annum by that date. We then have a whole host of secondary and tertiary clusters, which will be developed over time to support the delivery of that net zero target. Just a quick overview in terms of the incentives for green hydrogen here in the UK. I'll not dwell on this too much because I'm conscious of time, but we have the UK emissions trading scheme for carbon pricing, and we also have a subsidy mechanism to support hydrogen projects.
They are fine, nobody is complaining.
Okay.
We have ample.
Sorry, I'm getting a bit of feedback from the mic there.
Keep going, please.
Keep going.
Keep
Okay.
going.
So in terms of the subsidy for green hydrogen, it's very similar CFD structure to what we saw and has been successful in the UK for offshore wind. It's essentially bridging the gap between the cost of producing low carbon hydrogen today and the value that it could be worth to compete with CH4 natural gas in the market. I'm more than happy to share more detailed information or perspectives on the nature of that subsidy if anyone has any questions, but I'll not dwell on it given the time limit we have now. Finally, I just wanted to spell out the timeline for the subsidy auctions for hydrogen here in the UK. So we are currently advising multiple clients in what is referred to as HAR1, where the UK government will support up to 250 megawatts of electrolytic hydrogen production. Those final investment decisions, those contracts will be awarded early next year before the hydrogen allocation round 2 is introduced towards the back end of 2024. The ambition in the UK is to hold annual auction rounds from 2026, and we'll look to bring forward that 5 gigawatts of electrolytic hydrogen production target by 2030. Finally, just a high-level summary of what's happening here in the UK. So as I mentioned, we have a policy target of 10 gigawatts of production by 2030. This will be delivered through competitive electrolytic hydrogen auctions, but also the UK will develop a twin track approach. So we'll look to develop at least 2 or 3 larger scale blue hydrogen production facilities within those industrial clusters as well. This will predominantly be done through 15-year contract for difference agreements, which were successful with offshore wind. But for blue hydrogen, it's a prerequisite that they are connected to those carbon capture and storage networks ahead of those subsidy negotiations. I'm just conscious of time. I'll pause there and end my presentation, but thank you very much for the invite to this conference. And I did have the pleasure of visiting your incredible country just 2 weeks ago for the first time. And what a pleasure it was. And thank you to the next speaker, Anvesha, for the invite.
Thanks, James. Thank you very much. Now call on Anvesha Thakur, the partner for KPMG India. Ma'am, the floor is yours.
Yeah. Hi, everyone. While the presentation is coming up, I'll quickly introduce myself. I think Stephen was already introduced, but I just want to say one thing. Very proud that KPMG is working with the center as well as states on the green hydrogen agenda. And in fact, proud to say that we are working with states which will together deliver 50% of India's target by 2030. So these are all the leading states, including Gujarat, which I have a privilege to work with. जो लगाया था वही था यही है present. So I'll now give a little bit of a perspective about India. We've heard the global perspectives because finally it's about how we as now Gujarat navigate the whole green hydrogen adoption. So just to give a little bit of perspective about where we stand and more particularly where Gujarat stands in terms of being able to accelerate the green hydrogen development, I will quickly go into India's green hydrogen outlook. Actually, hydrogen outlook, a part of this will be converted to green hydrogen, which over years will become increasingly more as a proportion. So of the 90 million tons that James talked about, which is the global hydrogen demand, India today consumes 8% of that gray hydrogen today. So it's one of the biggest consuming countries in the world. 2 sectors, which is refinery and fertilizers, almost consume this whole 6 million tons equally. But of course, going forward, as we are looking at the whole gray hydrogen demand to double by 2030 and probably grow 4 to 5 times by 2050, a lot of this growth will actually come from new applications, which will be led by green hydrogen and its derivatives, such as ammonia, methanol, as Professor Sonde spoke about, in entirely new applications, which can be transport, it can be steel, it can be green chemicals. So a lot of future demand is not even envisaged, which will actually accelerate the whole green hydrogen ecosystem. So just to put that in context in terms of numbers, of course, the 5 million tons or 6 million tons of green hydrogen that the government aspires to do by 2030, the target is about 25 million tons of green hydrogen by 2047. So of the 30 million that we saw of gray hydrogen, 25 million, almost 85 to 90% is expected to come from green hydrogen by 2047, which is the 100th year of India's independence, and therefore it forms a target for the government. Concomitantly, how do we see the opportunity for electrolyzer deployment? About 60 gigawatt by 2030, growing threefold to 180 gigawatt by 2047. And why is it not fivefold? Because obviously efficiencies that will improve, because of which the electrolyzer deployment will be 3x and not 5x. Now let's look at what does it actually entail to drive a facilitative ecosystem and what will it entail for India and Gujarat. Now, if I'm just going to paint the whole value chain and talk about what are the imperatives here, the chain starts from renewables because that's the electricity that we need to split water into hydrogen. So what do we need there? We need abundant renewable potential, because renewable energy constitutes 70% of the investments and the delivered cost of green hydrogen. So that is where we need an upper hand, and we are, the 4th largest renewable energy developer in the world. So I think we're very, very well placed over there as India. Secondly, we need a strong grid, because while ideally renewable energy should be as close to the electrolyzer as possible. Unfortunately, because we are a diverse country with diverse resources everywhere, we may need to pull wind from a resource rich region for wind and solar from a resource rich region for solar and bring it together, hybridize it to improve the utilization of electrolyzer. And therefore, that means that you need to have very strong grids that will enable it. The electricity goes to electrolyzer. What do we need over there? Because electrolyzer and its systems constitute 30% of the cost of green hydrogen. So we need a significant manufacturing footprint, as Mr. Babu also spoke about, and we need to be able to produce this in a very cost competitive manner to bring this leg down. So then we produce hydrogen and then we store it, as Professor Sondeh said. So there, the importance of having that technology, an affordable technology to compress the hydrogen and store it becomes extremely important. Then you transport it, which could be through gas infrastructure, if you're looking at blending of hydrogen in gas, or trucking or trailers if you're going short distance. Ideally, for long distance, we should be using pipelines. And of course, the best case is if hydrogen can be produced on site, as is typically the case for fertilizers and refineries, so that we are completely obviating this leg of transportation. So what do we need for all this integration? We need very strong skills, which again, we have a very strong skill base in India, and we have academic institutes who are working as we speak in increasing the skill base for the country in hydrogen as well. Once the hydrogen is produced, there are multiple use cases that come in, right from the existing use cases of refinery, fertilizer, to new use cases like transportation. And something that we are not speaking about it yet, but a couple of companies are working on it, which is green chemicals. Huge opportunity for converting this into pharmaceuticals, green chemicals, which has actually got a lot of export potential, because let's not forget that EU is looking at taxation of embedded carbon on almost all products. So huge industries that we are not even talking about yet that will open up. So what does this need? What does this need? It needs the whole ecosystem development will need a strong demand. It will need ports, because at the end of the day, you also need to export, especially if the demand in the country has not opened up. And you need to explore adoption in new industries like chemicals that I spoke of. Now, having looked at that, let's look at Gujarat. So why are we talking Gujarat, and why are we saying we're very well positioned? Gujarat currently accounts for almost 25 to 30% of the current hydrogen production in the country and the requirement in the country. We have strong base of hydrogen consumers such as refineries, IOCL, RIL, NEARA, major fertilizer players like IFCO, CRIPCO, all of these present in Gujarat itself. We have an estimated current hydrogen demand of about 1.5 to 1.8 million tons from these two sources that I spoke about. But let's not forget that not only this demand is going to increase, because there's a significant capacity expansion that is planned by both refineries and fertilizers. So this demand is going to expand to almost 2 to 3 million tons by the end of this decade. But there'll be emerging use cases, entirely new use cases such as steel, transport, which will also materialize, which will add to this demand. And then we are, of course, talking about exports. We are a coastal state, so being able to export, and we are the largest state in terms of chemical industry as well. So a whole host of new use cases that can really increase the demand for hydrogen and its derivatives like ammonia and methanol. Let's look at the supply side. That was the demand side. So in terms of RE, I spoke about all the enablers that are required for hydrogen. So we need RE. Gujarat is again one of the strongest states in renewable energy, but also we have the potential for offshore wind, which we are going ahead with. And as James has spoken about, Mott has spoken about, offshore wind is a very major power, for steady production of hydrogen. So something that Gujarat, stands very well on. We have a very strong transmission network. I'm not saying there is enough. More has to be built, but I think the government is very cognizant of this fact, and we will see efforts coming in over there. Land spoken about enough. I think this is one of the most important things, and Gujarat has allocated land near ports, which is very beneficial to the hydrogen developers. Long coastline, for the obvious reasons, because of the ability to export, the manufacturing footprint, which enables you to have indigenized, component manufacturing, electrolyzer manufacturing, and a mature natural gas infrastructure, which is extremely important if you're looking at blending hydrogen in gas pipelines and using it for transport through CNG blending or with PNG blending. And we already have industry in action, major leaders like Reliance, Adani, NTPC, Oxford, which are already here. Just a very quick look at what do we mean in terms of investments. So we are looking at anyway, and probably I'm being a bit conservative, but I can't get ahead of myself and announce targets for the state. But if we are looking at 500 KTPA target to 1 million, target for Gujarat by 2030, it means an enormous opportunity, whether it is electrolyzers, where we're talking about 5 gigawatt to 10 gigawatt electrolyzer deployment. We're talking about renewable energy anyway from 12 gigawatt to 25 gigawatt range. We're talking about investments from 1 lakh crore to 2 lakh crore that can potentially be required by Gujarat, and jobs which can be anywhere from 60,000 to 120,000. So just to summarize, what are the opportunities when we are looking at scale up of green hydrogen derivatives in Gujarat? The potential for exports, the global demand for ammonia, which is currently at 180 million tons, is expected to grow to 550 million tons by 2050, and this will be led by green ammonia. There are opportunities for export to countries like Japan, Korea, Germany, which we're already seeing tenders from these countries. Refineries and fertilizers I've already spoken about. Projects are being conceived as we speak. New use cases, again, we've spoken about this. 18% blending in CNG and PNG itself can add almost 300 to 400 KTPA to the hydrogen demand. And then we are not even started, assessing what can it mean for steel, chemicals, etc. NTPC incidentally is already looking at gas blending in Surat. And maritime ports, which also I don't think we speak enough about, but this is a huge opportunity. Gujarat is on maritime corridors. There is bunkering opportunity, there is green shipbuilding opportunity, decarbonization of ports. So all in all, very well positioned state to take forward the green hydrogen story. Thank you.
Good. Thank you, Ambassador. We're going to change the program up a little bit under official request, and we have one question from the audience and one question from the online audience. We have about 100 people online on the online audience. So who would like to ask a question of our panelists? You have them on stage, they can't move, they're not chained, but they're in a very difficult position. Who would like to ask a question? Okay, at the back there. Sir, I'll come down to you. Much like a radio talk show host, how do you do? Could you say who you are and 45 seconds?
Yeah, sir, I'm Sandeep Dave, CEO of the group. We are expert in setting up the clusters, and we are looking forward to set up a hydrogen cluster in Gujarat. My question to Dr. Ramakrishna is, do we have a realistic price benchmark? Because most of the time when we talk about the hydrogen, the pricing is something which has come up, for a banking and all other approaches as kind of an unrealistic one. So do we have any idea about the current market offtake contracts which has already happened or it is in progress in India or in Gujarat elsewhere? Thank you so much.
Thank you. 45 seconds. So I'll answer in a bullet point manner. The electrolyzer cost will be about $800 a kilowatt. That's very clear. That's available to us. It can be brought down to about 400 to 600, but right now the one which we are building in Jodhpur is about $800 a kilowatt. The LCOE based on the current, whatever is the solar, is about 2.23 rupees per unit. And the energy consumption is about 58 units. At the grid point, where I'm measuring at the grid point, considering all the inefficiencies, about 58 units. So with this, when you really put an IRR of the order of about 14%, I'm not going for a 20% IRR, just want to keep it minimum, the cost can be put under about 270 to 280 rupees. Now, how do you really bring it from 270 to 100 rupees or below? There's a pathway, and probably I'll talk to you offline to say how this can be really brought down. But 270 is not the end of the story. This is only at the generation point at 20 bar pressure. From 20 bar to go up to 500 bar, actually we are neglecting this point. That adds to another 600 rupees. Hold your breath. And that is something which I think we need to do it. We are unfortunately obsessed with electrolyzers and not looking at end point, what is required from the generation point to the delivery point and the dispensation. Thank you.
So not 45 seconds, but close. Well done. We have time for one more question because the online audience is being very shy. Sir, I'll come down to you and not walk into something. Oh, good. There you go. Please say who you are and what your question is.
Sir, we are from GSFC, and I have a question for GPCL as well as KPMG, if you have clarity on this. Whether existing renewable energy capacity can be considered for green hydrogen production, or are you considering this point while framing the policy for state?
I can't comment on, what is included in the policy, but I can comment on the fact that in most states, we are looking at new renewable energy being developed to back the green hydrogen ecosystem and not the existing projects.
I hope I can answer who was the gentleman. Your question was whether you are taking up the present RE capacity for green hydrogen production. So Gujarat government has a very clear policy. There's a land allocation policy for green hydrogen. There is a RE policy which the government of Gujarat has very recently come up for. So in terms of land capex, it's a different scenario. Whereas we are keeping a separate cap on the RE power, something like 10,000 megawatt is the present cap for the existing RE projects. And for green hydrogen, the land allocation policy is different. So what we're trying to do is for renewable energy, we are going with a different policy. That's a 2019 policy for allocation of land and areas for escalating your RE potential. So that is about 10,000 megawatts per, if it's a PSU or a company or whichever it is. And in terms of green hydrogen, the limit capex is as of now 1 lakh hectares. So that's about half of it. So that's about 50,000 megawatts. So we do not want to mix up the existing RE capacity, which we need to achieve for 50% in terms of usage terms. And for green hydrogen, the policy is totally different. So whatever RE power is produced for the production of green hydrogen, that will be an entirely different ecosystem, and whatever is being used for RE power in terms of solar or wind or hybrid or offshore, that will be totally different. But in all, we want to scale up the RE potential. But it's both are mutually exclusive. Yes, thank you.
Thank you, sir. We did have a question from online, but we're not going to have time to do it. We're going to I'll put the person. I'm sorry, sir, we don't have time. I might apologize.
No, please be seated, please.
How do I can't, he's the host, I can't say no.
Anvesha, please be seated. Yeah.
Thank you very much for giving me the opportunity. Any specific reason, Arun sir, for keeping these two separate?
Very simple. We don't want people to mix up their priorities. That's it. A priority for green hydrogen is different. A priority for RE power is different. And most of the times you see there are common players also. So we don't want to mix up things. And we are very clear that green hydrogen target is 1 MTPA. So we go with that. And our RE potential is something about what we're aiming is, as of now, is 30 gigawatts plus another 8 gigawatts which we're working. So Khavda will have 30 gigawatts coming up in about, say, 5 to 10 years, 6 years. And the total RE potential that we are aiming up is 45 gigawatts. So that is separate. And this is 1 MTPA separate. Yeah, so that's all. Great job.
So we end today's the first session for technical, and I thank the panelists on the stage for their wonderful contribution. There's a lot of fuel for thought. And before I end, I would like to show my appreciation and GPCLs and governments by giving a token of appreciation to all the esteemed panelists. I call upon my colleague from GPCL, Shri Rajkumar, to come and give a token of thanks. It's actually an eco-friendly seedable gift to Dr. Ramkrishna Sonde, Professor, Department of Chemical Engineering, IIT Delhi. Next, I call upon my colleague Mitesh Patel to do the same for Mr. Amit Ketkar, Principal Consultant, Mott Magnon, Japan. And lastly, I call upon my colleague Chetan Prajapati to give the token of appreciation to Anvesha Thakkar, Partner, Alternative Fuel and Clean Energy, KPMG. Yeah, can we have the panelists? Can you just have a group photo and then we start the next session?
get the online people, speakers.
Yeah. Before I forget, I would like to, thank the other two panelists who have come virtually. Mr. Ahmed Halima, Hydrogen and Future Fuel Lead, Mott McDonald, and Mr. James McKay, Director KPMG from UK.
Thank you.
Thank you.
Thank you very much. Thank you.
Thank you for having us.
Just get their request right into.
Yeah. Anvesh, I request you to, come back because I think next panel is yours. Yeah, please. So we are actually running out of time. So we have two panel discussions. The first one is hydrogen value chain, global and Indian market dynamics, and which will be moderated by Anvesha Thakkar, Partner Alternative Fuel and Clean Energy, KPMG. So Anvesha, you are wanted back on the stage, and I'll invite the other panelists on the stage. Shri Rajat Seksaria, CEO, Green Hydrogen and Derivatives, Adani Group. May I have you on the stage, please? Chintan Thakkar, Group President and Head, Corporate Affairs, Wellspun. Vish Iyer, Global Chief Commercial Officer, Jackson Green. Okay, sorry. Subhash Kumar, Director, ACME. Pawan Mendirata, Head, Hydrogen SBU, Thermax. And Anish Ponwala, Head of Business Development, H2 Investment Business, South Asia. Please. As just before I start of the session, I would like to welcome all of the esteemed panelists. Invite PD BP Pagare, AVP Project GSFC to give a token of appreciation to Mr. Rajat Seksaria, CEO Green Hydrogen, Adani Group. I think Chintan is not doing. Okay, sorry. Yeah. I understand, Mr. Chintan, that I see him online. So welcome to the panel. I'll invite. I'll request Deepak Chawla, EQDC, to give a welcome thing to Mr. Yeah, please to Mr. Rajat Seksaria, please. Yeah, I invite Deepak Chawla, EQDC, to give a welcome token to Vish Iyer, Global Chief Commercial Officer, Jackson Green. Please. Next, I call upon Piyush, AVP Gujarat Gas, to welcome Mr. Subhash Kumar, Director, ACME. Is there? Yeah. Who? Is not there? Yeah. And lastly, I call upon Naveen Sharma, VP Gujarat Gas, to welcome Mr. Pawan Mendirata, Head of Business Development, H2 Investment Business, South Asia. Sorry. Good name. Wish. Yeah. And I call upon my colleagues from GPCL to welcome Mr. Anish Ponwala, Head of Business Development, H2 Business, South Asia. Irfan, you can do the honors, please. The stage is yours, Anvisha, please carry on.
Thank you so much. So I'll have to go straight off the bat, and since this is the World Cup season, I think that's an appropriate, kind of simile to start with. I couldn't have hoped for a better panel. We are going to be covering most of the supply side aspects in this panel, and then Steve is going to take over, more on the demand side, the consumption side, discussing the hard-to-abate sectors. So as I said, I couldn't have hoped for a better panel, but please excuse me if I'm going to put you in a bit of a spotlight here. So I'm going to go straight to Mr. Subhash Kumar, ACME. So ACME has been announcing plans for green ammonia projects, not only all over the country, but all over the world, in Oman particularly. Obviously, the offtake of hydrogen remains a key concern because of the gray hydrogen and the green hydrogen cost difference. I'm very curious to know from you, how is ACME looking at cost reduction? What are the levers that you see for being able to achieve cost reduction to enable offtake?
Thank you. And first of all, let me thank organizers for having me here. I think generally, when I was dealing with Energy Transition Advisory Committee, so my comments will not be necessarily from ACME perspective. They will be generic in nature. Of course, they represent the producers' concerns also. There has been a lot of buzz around hydrogen. A lot of discussions are happening. I think it is high time that the mandates, everything where we think that there is a requirement, actually it gets converted into mandates. So there has to be mandate, especially let's say in a country like India, probably there are only two major sectors which use the hydrogen at stake. So there should be an immediate requirement to shift to green hydrogen, and also a financing mechanism to ensure that both the sides, which is producers and even the people who are converting to hydrogen usage, they are compensated. Otherwise, there will be a reluctance. Second thing which I feel is necessary is also having a canalizing agency. Because at the end of the day, dealing with so many people for producers will be very difficult. We have a very successful experience of having safety as a good enabler. That actually helps standardize, and almost the risk is taken to the level of sovereign. So consequently, the cost of financing comes down. And this ties into my third suggestion, which is actually bringing down the cost of financing. In fact, as per IEA study released last week, a 3% increase in financing actually results in around 30 to 35% increase in the cost of projects. And last point, since I'm pretty sure that the organizers have issue of time, would be to look at the carbon markets. At the end of the day, the narratives need to change. See, at the end of the day, the world had a limited carbon budget, and somebody has consumed his share of carbon. Now, those who have not used their budget don't get a right to pollute or emit more carbon, but are at least entitled to compensation for cleaning the value chain. So the world needs to create a carbon regime which promotes the green hydrogen everywhere. So these would be my key suggestions in the first round, and if the opportunity comes, I will supplement in the next round.
Mr. Kumar, you have not disappointed me. Not only have you been extremely succinct, but I think you hit all the points on mandates, financing, having a sovereign level off-taker, carbon markets. These are absolutely the right, set of recommendations. I move over to Mr. Seksaria. Very keen to know that are there any, lessons or insights that you're seeing from around the world that you would like Indian government and state governments to kind of adopt when they're looking at scale up of hydrogen?
I think quite happy to be speaking in this forum My compliments to the organizers for having this event in Gujarat and inviting people like me here. Now, I think what you raised is a very important point around the world examples, right? Someone in the previous session said we had missed the bus in many sectors. I'm glad to say that this is one sector where the bus has not been missed by India yet. And we need to get our priorities right. So when you coincidentally, you mentioned Acme and Uma, so that was my previous franchise. I was working on those projects while I was in that franchise, that company. So there are actually a lot of lessons that are there which we can incorporate. And the first one is very important and it ties up to the topic of value chain, right? Someone in the previous session mentioned that there is $100 billion of funding lined up. So biggest commodity that goes into a large capex project like hydrogen, which has renewable power and possibly ammonia, is not steel or modules, it's money. And money is lined up. But what was not told is at what conditions those money is lined up, right? So financier typically demands a fixed return and a fixed revenue stream in hydrogen or if you sell derivatives. Now let me explain the complexity of the business, the technical complexity the other session members have had. So we need to produce modules. Module today is priced at 16 cents to a watt. Last year it was 32 cents. And prior to that again it was 16 cents. A variation of 100% in a matter of 12 months. Then you go to electrolyzers. The cost, if you go around the house, you get values from X to 4X. When we invite quotes from potential suppliers, someone can be quoting as high as $1 million, someone can be $500,000. That is a variation. Next goes steel, variation of 100%. Then you talk about international financing costs. SOFR was 1% last year, today it is 4%. So everything in the value chain is variable, varying by 2 to 3x, and you still need a fixed price for an output. And guess what? Yes, there is demand for ammonia, possibly hydrogen, and no one is willing to give a fixed contract. So the complexity in the whole business and the value chain is not about the technology. Technology will get into place. They are doing a good work. But how do you fix a business model, which is the biggest challenge? So I think I must also tell at Adani, how are we addressing it? Because to address this complexity, we manufacture our own modules. And to the extent we manufacture the back sheets and the glass for the modules, we manufacture our own trackers. We need a lot of wind turbines. We should decide to manufacture our own wind turbine. We are now manufacturing all our own electrolyzers. And we are lucky enough to have our own port, right? And we incidentally are also the largest transmission company in the country. So all the part of the value chain is where we want to have stakes, have a good presence, so that some of these variables which are there in the supply chain, which eventually impact the business model, is something which we want to have reasonable control over. And that is a lesson I have learned across the world. That today people are talking, there is a contractual risk, there is a project on project risk, there is a financing risk, because there are very few people in the world who actually are reasonably well present across the chain from the land onwards till the port, which I think is going to be important if you want to really scale up and achieve a 1 million ton in hydrogen in Gujarat or 5 million in India. So that's the play people like companies like Daniel.
Yeah, I think another very brilliant point, and this is something often ignored, that I think developers need to bear disproportionate risks, when you look at project development, because on one side, there are huge supply chain risks, which we have no control over. And on the other side, our off-takers expect fixed price, all risks to the developers. So it's in this situation, being able to deploy money and to expand becomes extremely difficult. So I must commend the strategy of actually value chain control through, backward integration and owning the supply chain yourself. I think that's a brilliant strategy. Pawan, I'm going to move to you and come to my favorite topic again, which is Gujarat. So Gujarat has a lot of potential, as you just heard me as well, provided you didn't go off to sleep. But what do you think can hasten the process of creating a big hydrogen hub in Gujarat?
So I think hello. So I think first of all, thank you, Nishwar and the organizers for having me here. I think it's great to see such a brilliant audience and speakers here and to learn so much by being part of this conference. And thank you so much for inviting me here. I think every journey to a large destination starts from a small drop. And while we are talking of very big ammonia project, which I'm sure will come up as we go along. But I think we also need to be realistic, and we need to also have projects, a micro activity which kind of also takes care of some of the gaps which we have in terms of the value chain, as Mr. Rajat said, which is, and the technology gaps, and I think Professor Sonali talked about this. So I think the way I see it is that while there should be a focus on very large projects, we should not miss the bus in terms of having a small hydrogen valley kind of projects which are supported by the state as well, in addition to the state in addition to the support of the center. Why I say that is, because we need to develop the competencies, and in order to bring down the price of the hydrogen, I see that as India, there are several gaps in supply chain, in terms of technology, in terms of experience, in terms of grid connection, in terms of the actual experience, how the equipment will behave in terms of transportation, storage, compressors, everything. So I think if there is some kind of a huge encouragement by the state to set up these small industrial clusters, and these could be projects as something like a 2 ton per day or a 3 ton per day, where they could be industrial off-takers, there is a 50% capex subsidy available, something like that, or a viability gap funding available. With the fact that, some of the, and also there is a trust that some of the technologies could be tried in these kind of projects, by some risk sharing mechanism, because if you put up new technologies, there will be some failure, there will be some issue. So some kind of these small micro projects of the size of 2 to 5 PPD, I think those need to be incentivized. There has to be a separate policy around that, which is different from the large policy, which is, different states are rolling out. So I think that's a very important gap which needs to be fulfilled. And Gujarat being a leader in this field, I would really appreciate if these micro or a small hydrogen generation or a hydrogen valley kind of a project policy comes out which supports startups and institutes and industry and academia and the other people to come together and set up such projects. So that's on the one very important part which I think is kind of missing and needs to be implemented. On the second part, of course, the policy of Gujarat has to come. We're all waiting for practically, but obviously, things like sufficient capex subsidy, something like a 30% capex subsidy, incentives on banking, availability of banking round the clock. Because there are seasons when there is no wind, there are seasons when the solar is low. So banking should not be available just, within a 1 month time frame, but probably on an annual basis. And obviously, this will be a very key part, because if we have to meet the MNRE's recent guideline, or a very stringent guideline of, I think, 2 kgs of CO2, I forget the exact number, but 2 kg of CO2 per kg of hydrogen, it's very, very stringent. Actually, this would require an RE of around 95%. And that means all the green projects should be fed by 90% green energy. This actually means that it's kind of round the clock. And if you have round the clock, I have seen, or we have seen that, the cost of energy, the cost of renewable energy goes up to 7-8 rupees, because you have to supplement it with battery. So I think banking becomes a very important part. But banking should be available not yearly, but probably on an annual basis. That's that. And as the banking goes up, obviously the transmission, the distribution network has to support it, because we are talking about huge amount of time. Is it feasible? Everybody will be banking in the daytime and taking out in the night time. Is it a really feasible thing? So I think that transmission and distribution really needs to strengthen.
Correct.
And the other thing is, I think also Mr. Rajat spoke about it, and Mr. Subhash spoke about it. There has to be mandates at state level, because there are state level organizations. There's, ISAL and all these are center level, but there are state level organizations. So state also has to drive the mandate for the different, for the organizations which are controlled at a state level and because that will give security on the offtakes. So I think these are a few of my suggestions. Thank you.
Thanks, Pawan. And incidentally, I think the suggestion on promoting micro and small enterprises is definitely very welcome, I think, by Gujarat because they have been looking at it. And luckily, you have everyone in the room to help you do that. There is IIT, there is ADB, who's who would probably be happy to finance. And there are developers, there are, electrolyzer manufacturers. So yes, absolutely. I think having the consortium going to do something like that would be great. And it would be the demonstration project that will give confidence to the industry as well. So now I'm going to move from development of projects to electrolyzers, which, I just want, Anish, that if you can help demystify it, because, we hear about a lot of technologies. We're hearing about alkaline water, we're hearing about SOECs. How do you see the relative importance of these technologies and what are the characteristics which will lead to the adoption of one technology over the other?
So, thank you for the invite in this very important discussion. Thanks to ADB and GPC. And thanks, Anasa, for the question. So, LinkedIn is the developer of hydrogen production projects as well as the technology provider. We have been also looking in, like Rajat mentioned, there is a kind of within the technology also there is a quite range of the cost you get. So a lot of people do the thumb rule and say this is the cost of hydrogen, but that's not exactly it. It is working out. So let me put it this way. Currently, even if you look at, we are developing a 4 major size of green hydrogen project. 24 megawatt in Germany on the PAM basis, 35 megawatt in Niagara Falls on a PAM basis, 10 megawatt in Singapore on the alkaline basis, 250 megawatt in Australia, which just got awarded, which will be also be coming up on the alkaline basis. So how we select it? So currently, Linde's way of looking is we also put a stake in the ITM power. And we want to grow that technology and learn along with the scale up. As well as our 24 megawatt of electrolyzer PAN with ITM power is commissioning. Niagara Falls, it's a Cummins PAN electrolyzer, which is also coming to the commissioning stage within 4 months of time. So we are not only looking at the technology, but the technology providers and its operational pros and cons. What we are learning is that the PAN is definitely coming out to be the better technology, but it's still not mature. It has two issues in terms of startup, in terms of the safety and the designing perspective, which we are fixing in terms of real term project. Alkaline project, which we are seeing that currently are still a best in class in terms of maturity and on the cost point. And the market, which is absolutely on the cost point perspective, alkaline is definitely going to be a critical technology to remain. So both are coexisting. Linde also started putting the scale-up plan for SOEC, which we definitely see has a lot of merit, but that requires another kind of integration skills where we can take the temperature high and continue to operate. And like Mr. Paul mentioned, unless we get a very consistent power, we will not be able to manage the SOE. So if I put in a very clear summary way, is where there is a good land prospect available and cost is very critical, but we are okay to stay with some kind of the variation of the hydrogen production. Alkaline is definitely coming out better. When the land requirement and fluctuation is not tolerated, it is going to be a future technology. And we are fixing the issues and we believe that within 2 to 3 years, it's almost can reach to the point of the alkaline technology. SOEC, which like your graph also shows, if we want to reach from the 5x to 3x, it cannot be alkaline or PEM, it has to be SOEC. And that is what we are also started working.
Thank you, Anish, for putting it so succinctly. I think even I've learned a lot from that, and I'm sure the audience have, and I'm sure that a lot of people just wanted to jump in and have their views. I could see Pawan itching to say something. I know that he's a staunch, supporter of one technology over the other, but I'll not say which one. So I'm going to come to Vish. Vish, Jackson's been looking at indigenization and evaluating the value stream of electrolyzer manufacturing for quite some time. What's on your view on being able to indigenize it and in a cost competitive manner?
Thanks to when we talk about indigenization, and it is especially in the light of, I would say, the recently announced policy measures from the government, I would like to bring discussion a very key point that we've practically faced over the last year, which I think is access to technology. And I think the initial part of that actually was more of learning by buying stuff and figuring out what really works. And if you just look at South Asia, and if you look at, let's say, stack technologies coming out of China and then Korea, just two countries, and I'm not even going to the Western world, the difference at times is 3 to 4x in the price. And so you're just talking about Asian economies right now, you're not even getting to West. So I think there is obviously a big disparity in terms of what exists between two countries, which can do it at scale, or I don't know, it's a matter of quality or many other parameters, which we, I think, quite honest, we yet sort of understanding and verifying ourselves. But I think therein there is also a challenge that we've seen, that let's say a Western world technology provider, or let's say Western world technology company buying a Chinese technology player and calling it Western world is allowed in India. But if we, as an Indian player, want to go and buy out a technology from China, that's not allowed. So I think this probably needs to be dealt with, and debated probably at a much larger level, because I think what we're doing is we're taking this whole scheme initiative back by 20 years, if we do that. And I think this is probably India's moment, I would say, for the next 2 or 3 years, that with all the policies that we have in place, with the kind of demand that we want to create, we can actually, for the very first time in the last 20, 30 years, create a very large local manufacturing industry by buying out technologies, by being the owner of technologies, by being the owner of patents. I think that is exactly what we need to figure out. Are we really sort of swallowing ourselves in rules which we can't follow? Could there be better or simpler rules? Why would we basically incentivize any Western world manufacturer buying a Chinese technology and coming to the country as a Western world technology? These are an Indian company trying to buy out, let's say, this Chinese technology available in the market. I think it's a powerful debate because we are talking about owning and operating the technology. We're not talking about just leasing a technology from someone, right? So I think this is a larger scheme in debate. The second point that I think has also come to a lot of discussion in the last maybe 4 to 5 months since the announcement of the policies is around the PLI scheme, where I think it also leads to a point on enabling factor, which is I think demand, which I think the next session is going to cover. But I think the absence of demand and the intention of the policy being to scale up, I would say, manufacturing. Any manufacturer would probably want to put a giga scale facility, and in proportion to that, if you are really forced to sell a lot of the initial produce in the local market, in the absence of demand, it gets too difficult to model as to what it's going to be. So I think there is needs to be a lot more thought. I would say we've got into sessions with MNRE, Seki, and all these chaps on a regular basis discussing these points. We also wanted to get a lot of investors involved in these discussions, managing a lot of, I would say, our own fraternity in terms of the manufacturing industry. But I think there are quite a few sort of points which need to be addressed. I think the first and foremost being access to technology, because we can't keep buying stacks from Korea at 4x the price, or maybe stacks from the Western world at 5x the price. But we can actually produce it much lower in India once we start owning the technologies that are available for abundance in China, to be quite honest. And I think just shutting our doors to not be able to buy those technologies is actually painful. So I think that's probably a point for a larger discussion. We just wanted to table that point because that is something that maybe all homegrown manufacturers who aspire to become a gigascale producer with local patents in India would want to aspire towards?
So thanks, Vish. I think definitely if we need to bring down the cost, it has to go to giga scale and many such factories, and we need to do whatever we can to allow that to encourage that to happen. I'm going to move over to Chintan, who's there virtually. Chintan, are you there?
Yeah, I'm there. I'm there, Anisa.
Chintan?
Yeah, can you hear me? I'm there.
Yeah, okay, great. Sorry to keep you waiting, Chintan. I'm going to ask you about skills. So as Wellspun, you are starting your whole journey on hydrogen, looking at, in fact, the whole energy transition area. One of the key aspects that the government really wants to focus on is how to build the necessary skills and whether we have the necessary skills for energy transition, green hydrogen. For green hydrogen itself, we're talking about 6 lakh jobs, that are going to be needed by 2030. Do you think that we have enough skill sets in India to address the entire requirement? Where do you think are the gaps?
Yeah, Vanessa, thank you very much for having me there. In fact, when we are talking about the skilling and manpower and workforce, I think this is our strength. If we put it in 2 baskets, green hydrogen is nothing but green and hydrogen. So we are talking about renewable, we are talking about hydrogen and ammonia. So good news is, yes, renewable per se. I think in previous session, we were talking that India has done very well. And in last decade or so, we have developed a very good ecosystem for project execution for renewable. As far as green hydrogen and green ammonia is concerned, we have been consuming and producing green ammonia and gray ammonia and gray hydrogen since ages. We have a very well-developed ecosystem of chemical companies, pharma. So as far as workforce is concerned, I think it is not a challenge. I don't see challenge, rather I see strength. I've been going around to, international conferences on, green hydrogen, be it one which was in Netherlands or Germany. The bigger concerns were, the key lies, whatever technology is being developed in any part of the world is becoming global and is reachable, like it is reaching to India, China, everywhere. So the key lies here is who will be the fastest executioner of all these projects. And that is where I saw a challenge where we were talking in Europe, where they have technology, they have other things available with them, but the project execution and speed at which we were able to do because of our manpower and availability of the skilled manpower rather is what I see strength. And I will come to your favorite topic, Gujarat. In Gujarat, if you see, a lot of projects, major projects are coming in Gujarat as far as green hydrogen and this thing is concerned. But the biggest challenge is this is first time being developed in a very marshy land and arid area. So that is where we see a little bit of challenge where, we are not geared up enough to work on such huge projects. We are not talking 1,000, 2,000 acre. We are talking, 3 lakh, 4 lakh acre of land with, water accumulation and marshy land and arid. So this is where the civil engineering of the state will have to gear up, because not only the technical challenge, but all these projects are coming in the same time. So the scale at which we will require the civil engineering support and engineering support is something where we will have to gear up ourselves. But having said that, government of Gujarat has done whatever it could do, in terms of incentives, in terms of land, ports, everything is available. So now they have done their bit, and we private players will have to, stand up to the occasion, and we'll have to collaborate with academia, engineering colleges, not IITs. This time we will have to work more closer with ITIs and get our, act right. So yes, these are some areas where we will have to, just fasten up. We have very good example. Information and technology was something which, technology was available and workforce were required. And India in past has proven its mettle in that. So this is the time. Yes, we will use this requirement of workforce and availability of workforce as our strength, and will excel in it. That is what I think about it.
Thanks, Chirag, for giving us this holistic perspective. So I know that we have a massive time overrun, so I'm not going to go into the second round of questions. But any one of you or few of you just want to leave one message for the government of Gujarat. What is the one thing that you would like Gujarat to work on to accelerate the green hydrogen ecosystem? Just one thing, please. Yeah.
So I think one thing for the country and Gujarat would be to work on R&D to replace the usage of or reduce the usage of exotic materials. That will bring down the cost of entire value chain significantly.
Thank you. Anybody else would like to add? Yeah. Here's your chance.
I must really compliment Gujarat government because I worked with other states. Probably Gujarat government is the only government which has a proper, robust land allocation policy separately bucketed between renewable and hydrogen, and for very valid reasons. I think one area where it is our expectation, and I'm sure authorities will respond, we'll require flexibility in terms of how the policy evolves over next years. Because every now and then we discover something else, and which we may have not discovered earlier. We would want that kind of flexibility, keeping in mind the fit for purpose. Right? For example, we need land for hydrogen. We'll develop a hydrogen plant. But there could be occasions when we will be generating power over and above our electrolyzer capacity. So what should we do? Should we let that power go waste, or can there be a ways in which we can commercialize it? So there would exist bits and bits which will keep coming across our journey, and which is where we'll work as a partner with the governments and authorities so that we come to something which is kind of sustainable. So that would be my only request and advice.
Anyone else would like to add?
I think everybody is talking about challenges and barriers. I think there was a question about what kind of opportunities we have, not just in context of Gujarat, but, all of us talk about electrolyzers and things like that. But I think, and that's where the technology is still getting developed. We are dependent on outside companies, etc. But if you look at the kind of, and I'm from a company now which is a company in terms of a very high engineering strength, in terms of indigenization, and in terms of a lot of things that we do in-house manufacturing, etc. So the opportunity that I think this sector is opening up is in terms of the balance of plant, balance of skates, balance of stack, even the hydrogen compression side, the storage side, And there was a study which I came across recently, and I kind of went through it. And what I realized was that if we look at an installed capacity of around 6 gigawatt of electrolyzers by 2030 across India, which is a conservative number, there is an opportunity of, and some of the export potential to countries like Middle East and Southeast Asia and all that. There is actually about a $20 billion of opportunity in terms of leaving aside the stack, and working with companies on these balance of stack systems and hydrogen purification systems and things like that. So we are staring at a $20 billion opportunity in the next about 5-6 years. I think I see that Indian companies, Indian engineering companies, and manufacturing companies have a very big, can really look at that opportunity and kind of turn it into a very big opportunity for them. So I think from a perspective of a manufacturing and the engineering and all that, this is a great opportunity which India should not miss, the Indian companies should not miss, and this should be one of the focus areas.
Thanks, Pawan. I think that's a brilliant point. Thank you for adding that. In terms of balance of payment and balance of stack, actually, India has full indigenized capabilities. So we stand to gain absolutely in this global requirement for ancillaries, balance of plant and balance of stack. So thank you for adding. Anish, Chirag, were you trying to say something?
Just wanted to make a quick point. As far as government of Gujarat is concerned, I think they have played their role very well. Land allocation is in place. Ports are Kandla port as such has been developed, has been declared as a green hub, and there are port availability is also there. But like other projects, we have seen whatever project required the central government infrastructure requirement. There was a lot of hand-holding in past. So, with big players like Adani, Reliance, and all big names, they will start and very fastly they will execute project and renewable will be produced. But the evacuation of this renewable energy is still with government. So CTUs coming from PGCL, right? There can be a scenario where we private players are ready with our energy and government has not executed their PGCL and CTUs are not in place. Now that can turn down the entire stuff. We as private players will put everything behind executing our project in time. If that happens, I think we will require a very strong hand-holding between government of Gujarat helping us to coordinate with the central government and place CTUs in time.
Thanks, Chirag. Thanks for bringing up the transmission point. Very quick points if something needs.
I think quickly is like everybody mentioned that this is the place where India is entering, and if we see lot of places, the hydrogen and the gases is an infrastructure which is required for a lot of industry to grow. And hydrogen being the more application, we have in Gujarat lot of clusters, which if even can be put as a state, infrastructure developed already ready with the clean energy, either the CO2 capture and take the CO2 or the hydrogen as an infrastructure available. That will help lot of industry not to look at a very small project, but available that energy at a cluster level that helps them to start already bringing the carbon neutral or the reduction of the carbon in their balance sheet as far as they are able to take those energy, whether hydrogen as an energy vector or hydrogen as a gas requirement for the project, helps them, but not looking every industry a small to big, looking at the small projects and then looking at their viability.
Thanks, Anish. Vish.
To just mention the expectations from the government, I think it's very simple. I think I still remember 13 years back, it is the same trio of GPCL, GPNL, and ADP that came together. I would say the country's first large-scale infrastructure on renewable energy and the solar park at Charanka. And I think that still stands as a beacon of what an industry can be built on. So my simple suggestion would be just ensure that there is demand and supply will follow. I think developers will follow, investors will follow, but I think it's just about creating demand, which I think the government has done well in the last few years.
Thank you. I think all very, very brilliant points. I'm just wondering if we have time to take a couple of audience questions. So I see so blame Stephen, not me. 2 questions. Okay. Please keep the question very succinct and let us know who you want this to be. I don't think we have questions. I think we have done a very good job. Thank you so much, and thank you, my panelists. Thanks.
Panelists, please seated. I would like to appreciate you all the way coming to here for this conference, and as a token of our thanks, we have some mementos for you to take away. The seedable toolkit, eco-friendly. I call upon my colleagues from GPCL and EPD. First, call Ami to give the token of thanks to Mr. Rajat Seksaria. Rajat Seksaria, please. Yeah. No.
Thank you.
Chintan, if you're online, I thank you for your presence and wish you are here to take the token of appreciation. Either way, we'll give it to you in the office. I call upon to give a token of appreciation to Wish Iyer, Jackson Green. RG Patel, yeah. Thank you, sir. I call upon Bhavesh Patel to do the same for Subhash Kumar, Acme. Thank you, sir, for being on the panel. I call upon Bhavesh Vegda from GPCL to do the honors for Mr. Pavan Mehta, Thermax. Thank you, sir. And lastly, I call upon Gargi from GPCL to do the honors for Mr. Anush Punwala. Yeah. Thank you. Thank you, sir, for your kind gracing the occasion. And I think we have done. So let's have a group photo and then we will move on to the last session for today's conference. Yeah. Before I move on to the last and final session, I invite Shri Yogesh Chaudhary, Managing Director, DGVCL, to come on the stage. We would be honored to felicitate you. Requesting your kind presence, sir. And also Arun Mahesh Babu, Managing Director, GPCL. Yeah, okay, sir. You're most welcome. Sir. Now I move on to the final panel. Steven, you're back on the stage. He'll be moderating the last session. We have two panelists who are going to be virtual. Yunji Park, Associate Expert, UNIDO, and Bratin Roy, Senior VP, Industry Service and Sustainability, Asia and South Asia, and Middle East and Africa. TUV, SUD. So these two, I would request them to be shown online on the screen. I hope they are there with us. And I'll call the panelists who are physically present. Mr. Arnav Sinha, VP Sales, Commerce, Grenco Group. Mr. Sanmit Ahuja, Senior Advisor, Green Hydrogen Organization. Abhinav Sultania, Energy Specialist Consultant, ADB. And lastly, Mr. Mudit Jain, Head Research, Tata Capital. I'll again have the honor to do the honors. I'll ask NG Korat from my office to give a token of appreciation to Mr. Arnav Sinha, VP Sales and Commerce, Greenco Group. Thank you, sir, for being on the panel. Yeah, I invite Rajesh Shavdani, CFO, GSPC, to do the honors for Mr. Sanmit Ahuja, Green Hydrogen Organization. I call upon Jay Shah, GIPCL, DGM, to give a gesture of thanks of honor to Mr. Abhinav Sultania, Energy Specialist Consultant, ADB. Thank you. And lastly, I call upon Mr. A.R. Shukla, Senior Manager, GNFC, to welcome Mr. Mudit Jain, Tata Capital. Thank you so much for being on the panel, and off to you, Stephens. Carry on, please.
Thank you, sir. And so the final panel to this session is going to go a little bit more on more regional issues and talk about things which are related to not just India and not just Gujarat, but a more global perspective. So the first person I'm going to ask to talk is Yunji Park from UNIDO. And Yunji is going to talk a little bit about the problems we have with standards and give us an idea of what's actually happening with standards. Yunji, the floor is yours, ma'am.
Thank you very much. Thank you for the organizers for having me today. And it's my pleasure to shine some light on what is UNIDO's view on the common global standards for green hydrogen. So standards are fundamental in facilitating international trade and determining the safety and sustainability of hydrogen. And I think it's also well noted that the definition of hydrogen would be slowly shifting from colors of green or blue towards carbon intensity thresholds. So this will make it very necessary to understand the full life cycle of greenhouse gas emissions so that we can produce low emission hydrogen. Several considerations also need to be taken into account for an international framework on hydrogen standards. So at present, the development of the related capacities to create these supply chains for the trade of hydrogen and its derivatives are quite in early stages of development. And we believe that we would require significant investment and policy support. And most importantly, to engage and align a number of global stakeholders so that we can engage in trade. We would also need to enable our developing country counterparts to participate in the international standard setting process so that all aspects of standard setting, including the scope, the key definitions, and the content could be discussed and aligned. So what is UNIDO doing to correspond to this? Well, currently there are a number of global hydrogen standardization activities which are performed by ISO and the International Electric Technical Commission, to name a few. And within this landscape, we are cooperating with ISO to finalize a methodology which measures greenhouse gas emissions with the production, the conditioning, and transport of hydrogen to its consumption gate. And this will be finalized and accepted in due course. UNIDO is hosting the ISO-TC Technical Committee 197 Hydrogen Technologies plenary session within the upcoming week of 13 to 17 November, and we will launch a methodology in the upcoming COP28 in Dubai. And with this effort, we want to increase the knowledge and insight within public and private sectors so that there could more developing country counterparts could better participate in the standard setting. And based on this, we believe a lot of there could be another viewpoint looking beyond export potential and markets that can also be provided with enabling environment so that we could further develop net zero industrial development within the countries that are engaged in this standard setting process. So I would like to just emphasize on these points. Thank you.
I appreciate you getting up very early in the morning where you are. Next, we're going to move on to Mr. Anava Sinha, who's the VP of Sales and Commercial for Greenco Group. And he's going to tell us a little bit about the applications of green chemicals and a little more detail about that environment, which we haven't really talked about yet this morning.
Thank you. I hope I'm audible. Yeah, I hope I'm audible now. Yep. Well, thank you, Stephen. First of all, thank you for having me here. Absolute privilege. So green chemicals is an interesting subject, and I think this is
is opposed to me because of the recent announcement that Infosys has done regarding opening up of the platform. So the question is, do we also go for the green chemicals business now? But I would say that the new platform has been built entirely to go after the new chemicals business or the green chemicals business. Now, I'll give you a perspective, or rather a seller's perspective, or seller's understanding of a buyer's perspective of how and what is green chemicals, or how we sell that to the world. And I'll come back to the statement later. But first, what I would say is, what are these green chemicals that we're talking about? And the biggest one of them, and we often tend to ignore it sometimes, is green ammonia. It remains the overwhelming favorite, and it's our favorite too. So in the next 5 to 7 years, what we're aiming to do is to have 5 million tons per annum capacity of green ammonia to be available in country for use either in country or to be exported overseas, right? And the demand is there, and we can see it because we have, one of the announcements that is already in the public sphere is the agreement that the Greenco Group has got with Uniper of Germany for offtake of 250,000 tons of green ammonia per annum from our facility in Kakinada. Probably early 2026 is what we are looking at. So the demand is there. The price positions are there, favorable enough for us to be able to do it in a way that will be, that will make the business viable. Now, beyond green ammonia, of course, the second big favorite would be methanol, and there are plenty of opportunities that are there. When we start talking about methanol, whether it goes towards sustainable aviation fuel, or we go into the pharmaceutical side, or we go into the chemicals, such as MTOs, MTAs. Olefins will obviously play a big part, and with the world or the petchem, the refineries especially moving more towards the petchem side, which will need to be green. These will play a big role. But end of the day, the question that comes to mind is, why would a buyer buy a green chemical at all? The three reasons that I could think of is A, they're cheap; B, that the buyer has some sort of a green commitment that they want to adhere to; and C, they're being forced to do it. And probably D is a combination of all three of the above, and which is likeliest of the cases around the world today. And which is where, when it comes to the question of whether we are looking at a domestic demand or an international demand, these three factors, or these four factors, if you would like, play a very vital role. Today, there is a regulation in Europe, and there are more regulations that are coming up there. There are other countries that are also coming up with their regulations. There are international organizations that have already announced their net zero goals much earlier than many of the countries. For example, 2030 and 2040 is not something unheard of in terms of individual organizations' net zero goals. So they are the ones who are more likely to purchase these green chemicals, and they are the ones that we are targeting, of course, in the early stages. Now, the same is actually true for India, and that's why we're looking at a mandate from the government, which is the third category, where people are going to be forced to use this. And the bedrock of any industry in any nation is going to be domestic sustainability. And for that, it's absolutely a must that Indian organizations, whether it's a state-owned or a privately owned organization, starts purchasing these green molecules, which again, the base of it is just going to be green hydrogen as far as we are concerned. Right, and we look forward to those policy changes, regulations, and we hope to see further advancements in that.
Wow, 3.5 minutes masterclass in industrial chemicals. Thank you, sir. Next, we're going to hear from Mr. Bratton Roy, who is the Senior VP at TUV SUD. And Bratton, I'm going to pose a question to you about safety. A lot has been said about hydrogen safety and the challenges in terms of manpower, capability, and guidelines. I'd be really interested to hear what you think the pathway forward is. Can we get Bratton up? Are you there,
Yep,
sir?
I'm here. Yep.
Excellent.
Okay, thanks. Thanks for bringing me here and asking this question. Yeah, I mean, I think that we all know that hydrogen is flammable. It has a wide explosion range. It says we should have safety measures focusing mainly probably on risks of leakage and explosion. But one thing is also there that hydrogen is not completely new. And well, the color might have changed. And so the application of hydrogen, whether you are talking on pipeline, whether you are talking on storage, whether you are talking on the production, if you are talking on low carbon hydrogen, the only change in green is happening basically in the electrolyzer part. And probably I would like to highlight one thing. Yes, there are less experience of the industry or the countries related to green hydrogen because obviously it's new. But application wise, I think everybody has experience. And now, if I bring this green aspect here, the electrolyzer part, I would also like to highlight that well, there could be various standard in various countries, but there is also ISO standard, which is ISO 22734, which very clearly say that the hydrogen electrolyzer and various application, what kind of system would be there. And various application means include industrial, even resident. So the standard is very clear that what could be the operating condition, what could be the risk management condition, what could be the mechanical condition, control testing. So there is ISO standard. Country-wise, also, even in India, if you see, because there is less time, I will not go into details of the entire part. But if I take a very classical example of storage, I think everybody talk on safety and this hydrogen storage. Even in India, say, for example, we have a standard called IS 7285, which is basically like standard for cylinder storage up to 400 liter. So nothing is not there, is not like, probably this need to be extended. Similarly, there are a lot of ASME standard, which is followed for pipeline and part, which can be used. So in brief, what I meant to say that yes, it's important. It's important to have a uniform safety standard, but we are not starting from zero. There are standard, there are application. Yes, certain portion would be added, but it can be done.
Just to follow up on that, in terms of getting those standards implemented and capability, could you give me a short 10 or like minute answer about how you think that could happen both in India and globally?
Well, I mean, for the safety portion, definitely there will be little amendment is required on the IS standard, which is there in India. Maybe the standard can be a bit more synchronized with the safety standard, like say NFPA, and also that there is a synchronization on safety. But I still touch upon, because earlier they both talk about this hydrogen standard, and Arnav, we have discussed before as well. There is a requirement of a synchronization of, okay, color may not be important, but still when you are talking international, because we are quite involved in European Union or in some country on the standard, I think there are a lot of things that to be done related to synchronization, because certain country, there are three key differences which also come. One is threshold. Sometimes threshold is different. One is boundary, and third is this correlation and interlinking. So as an investor perspective, it's important to have a more synchronization of international standard. Yes, ISO is working. We are also pretty part of committee, but yes, still, I think that the synchronization is important. Okay, safety is one, but when you are talking on this certification of green or low color agnostic, a synchronization of various standards is important.
Very good answer. Safety is one issue that we're very concerned about, because if something goes wrong, it'll directly impact the whole industry. So we need to probably spend a bit more time on that otherwise. Now I'd like to talk to Mr. Mudit Jain, who is the head of research at Tata Capital. And sir, could I ask you a question about where your thoughts on, the hydrogen space? There's a lot of uncertainty we've heard today, but you've also heard a lot of things going towards being more certain. How do you see the investment environment for that? And what are your thoughts on how you can take part?
Thanks, Stephen. First of all, thank you, GPCL and EDB for the invitation. And Stephen, thank you for not making me the last obstacle before lunch. Coming on to the point at hand, well, we have seen a lot of optimism today, and you have put the pessimism onto me to answer that particular point out. And good part is that since we have a stellar panel before us, and even in this particular session itself, there is nothing really much to add. It's always about repackaging all the things which have already been said. So let me do that with the lender's lens here. Basically, what the three keywords which you are mentioning is about the capital intensity. Second is about the offtake risk, and third is about the price premium. The last two, when we look at Gujarat, as Babu sir and Pradeep has mentioned, it is basically the place where solar revolution of the country has started with the first 1,000 megawatt project. However, it really came into the shape when viability started happening on the solar projects itself. On that particular front, let's look at the part in general. Is the green premium, is it really available for the consumers of the world and specifically for India? That green premium wasn't there for solar when the revolution wasn't really picking up. The same thing happens for electric vehicles. Consumers wait for parity to come before they start taking that adoption route and do the investment. Because of that non-existing green premium, this green hydrogen market is at the loggerhead. On one hand, we have the conventional hydrogen market, which basically works on spot market and basically with high volatility, as Rajat mentioned. On the other side, there is a market where it can be driven by a fixed cost contract. Between the two, today, what will work is on the latter part. You will require a fixed price contract for a longer duration to really ensure that the project will ultimately give you returns over the long duration. However, the market will move gradually from the latter to the former. Instead of a fixed price contract, it will move towards the spot market, which is happening in the renewable space today. We see lots of projects coming into the exchange market. And by that time it happens, financing will become very fluid. There will not be any dearth of financing instruments. Today we see what kind of instruments are working in the Indian renewable space, and same thing can be replicated for the hydrogen. But what about today? For today, any project to come up, it can't really work on the spot market fundamentals. Since the volatility is too high, it can't work on the financing field from the lender's perspective. Equity risk is there for that particular purpose. But to make it happen, it will require all the things which have been said in the past by different panelists. There are two kinds of instruments. One is basically the mandate part. Either it could be the mandate of hydrogen purchase, or second would be the similar kind of application which CBM has been done in Europe. On the other side, there are incentives. Now, these incentives are and can be in the form of contract for difference. PLI is not really commensurate with the price differential that there is. But most of all of this will require a policy consistency for a longer horizon. Because a project which is funded today will look more expensive as time will pass, since conventional cost will go up and the price of green hydrogen will come down. As a result, the project which is funded today will look very expensive 5 to 6 years down the line. That policy consistency will be the key, because as we are talking about all kind of government interventions, including the banking and the grid, the cost of that particular grid is not really being factored in the cost of hydrogen today. But the moment we start putting it up on the projects which have been funded 5 years back, it will make those projects unviable 5 to 7 years down the line. And that is the dilemma where lenders are facing today. What kind of policy consistency will there be? What kind of structure will there be 5 to 7 years down the line? And how can the project which is funded today can make sense of it? I hope I have been quick in responding.
Wow, thank you for that. Great answer. I think the issue about how you protect those people who are first into the market, who take the risk, and figuring out products that can offset that risk or incentivize that risk that aren't just subsidies is a very good point. And I thank you very much for that. We'll now move on to my colleague Abhinav Sultania, who's going to tell us a little bit about what the multilateral development banks can offer. And ADB, he's from ADB. He works as a consultant to us.
Thank you, Steve. I'm going to give a pretty broader overview. We do have high offtake price. Am I? Yeah, you're on. Yeah, okay. We do have a high offtake prices as we are speaking. But these technologies, whenever we have started, for example, all those things have been covered. Solar, when it is started, was not cheap, and probably green hydrogen is also not going to be a cheap technology when we start. But eventually it will come down. The prices will start to go down. So we should look there are various parameters for a green hydrogen manufacturing. It cuts across hard to abate sectors of refining, fertilizer, and the end uses are also quite extreme. So the low hanging fruits really where the incremental cost should be invested and can be looked upon immediately are the ones where the end use and the production and the supply is at the same spot. And then we can look after the long-term distribution planning and the export products in a long run. So we need to, I think government has come up with all the policies on the supply side, incentives, and standards are there in place. It's time we should start looking more on the demand side adoption, and smaller projects with small offtakes are one of the ways. The other ones are the long, big projects. So the big ticket projects and big investments are needed to accelerate this type of technology. And big firms, big corporates, they have the balance sheets, and these project finance will be probably not sufficient, and they can take up the burden and start these big projects, and that can create the journey which India envisages to be a leader in, and we can do as a country is what I believe. Just to add, Steve, as Pradeep mentioned in the beginning, ADB as a multilateral development bank, we have a history of financing these RE projects, which Pradeep has already talked in depth. And we have that $100 billion, which is not sufficient, which we have already spoken about earlier as well. But we do have that $100 billion, and on mitigation, which is a green hydrogen technology, is a focus on mitigation side. There's a $66 billion financing available. And ADB, as a multilateral development bank, has access to blended finance, co-finance, loans, equity, grants, both on the public side and on the private side. And we do provide knowledge, technical assistance along with it. So, and we are here, we have started to see some early inquiries for small ticket projects, maybe in the range of $20 billion or $30 billion, and few, maybe 2 or 3 on big ticket investments around $400 million and $600 million. And we are here to interact with more stakeholders. We have to be more consortium oriented, and we have to start thinking in that line of taking help of all the existing financing facilities and government help which is available, and along with the corporates take next step and start the projects. So happy to, I believe that's what we should focus on, is it.
That I think the point that was made by Mudit and Abhinav was that Gujarat was the center of the collapse in the energy price with some of the early projects with solar farms, and ADB was supportive of some of those projects, and then that was scaled across the region. Pradeep recently worked on a project in Cambodia that had a massive decrease in the tariff of electricity from solar. And that journey took time, but we've got a lot of learning that we can bring out of that. And now I'm going to put my friend, Samnit Ahuja, who is a senior advisor to the Green Hydrogen Association. I'm going to put you on the spot. So I'd like for a moment for all of you to think that you're sitting on a CCTV camera and Samnit has just got into a lift with a head of state, and the lift breaks down and he has 5 minutes, or actually 3 minutes, to convince that head of state about what he should do from policy to make green hydrogen happen. And after the 3 minutes, the security guards will break in and free the head of state from his grip. Your time starts now.
It does start, Steve. I'll pause you and say, when I was in my business school, the same question was asked to me, that think you're going to a male toilet, right? And you have 30 seconds. The CEO comes and stands next to you. You have 30 seconds. Good. Thank you. Thank you, everyone. And the organizers for having us here today. And I've listened, and Mudit, I think, brought it very succinctly that there's nothing new that any one of us will say. We all kind of know, but I'd like to bring a slightly different perspective. And it's a little bit of reassuring perspective that don't think it's just the engineers and the policymakers. Us bankers are also working very hard how to make this thing happen, right? And when we look at the green hydrogen economy, we look at risks. So we have mapped out more than 45 individual risk classes in that either prevents the green hydrogen economy from jumpstarting, or if you mitigate each one of those risks using the 40 plus financial instruments, then you actually start seeing some light at the end of the tunnel. And the biggest risk, as all of you have said, is the market risk, right? Now, there's the mandates as a lever, there's those with slightly more bigger appetite to buy green, as my colleague mentioned. But there's also the first point that you mentioned, that you make the pricing attractive, right? So we look at wholesale finance first before we look at project finance. If we bring wholesale market finance into the country, and this is for every country, not just India alone, you start to reduce the price differential. So the first and foremost, the biggest intervention that government of India can make, apart from mandates, is to bring a market maker in the middle, right? A market maker like SECI. SECI's already been nominated as one of the key proponents to unlock the hydrogen economy. But SECI has to play a role much more than of an aggregator. It has to play a role of a market maker, right? And Mudit mentioned, fixed contracts. So all of you need at least 10-year plus contracts, right? But there's not 10-year plus contracts on the buy side, right? So that's the role of the market maker, which is to absorb three fundamental risks: the tenor risk, the price differential risk, and the volume risk. The tenor and price differentials being the most important. Now, let's look at the price differential, right? The price differential is addressed through blended finance, right? So we've done extensive modeling, and Pradeep will discuss with you. If blended money in rupee terms was available at 6.8, 6.9%, and RTC power was available at 3.5 rupees a kilowatt hour, and I say RTC power, not RE power, we are within 100 rupees price differential between green and gray, 100 rupees. Now, government of India has already said, look, we'll bring mandates, or we'll also give an operating subsidy of 50 rupees, 40 rupees, 30 rupees, tapering subsidy on the OPEX, which leaves just 50 rupees on the table, right? And I will not accept the fact that there aren't carbon markets that will not fund that 50 rupee gap. So we are within striking distance of funding green hydrogen. And blended finance is the norm, right? But blended finance will not remain a permanent instrument. It's an instrument to jumpstart the market for the next 5 or 7 years. Once the market is jumpstarted, we need $300–400 billion a year. Where's that money coming from? We've also identified risks in the Indian banking system. It is stretched to the limit. It understands RE risk very well, but it's stretched to the limit on funding renewable energy. There's counterparty risk, there's net sector exposure. So we have to go to institutional capital. There's $100 trillion of assets under management in institutional capital. Now, how do you unlock that money? If it's foreign capital, the first thing they look at is foreign exchange risk, right? The FX risk. Rupee keeps on depreciating, so there's a significant FX risk. But there is a financial instrument. So a sovereign to sovereign FX swap is a financial instrument that will address the FX risk. And InvIT's Infrastructure Investment Trust is a fantastic vehicle to unlock both equity and debt capital to tap into those institutional money. there was talk of technology risk. There is absolutely enough evidence that once the first of a kind, what we call FOC, first of a kind commercial demonstration project is funded, the NOC, which is nth of a kind, will happen already. So our journey has to be FOC to NOC, fund the FOC bit, and there are dedicated funds. I'm involved in establishing a fund, about 250 crores worth of capital available for funding the first of a kind demonstration projects. And later this month, there is a new intervention by the sovereign, which is called a AAA effect. So make technologies accessible, affordable, and then available, right? All of you said technology risk exists. There is electrolyzers being manufactured elsewhere in the world. We can't bring them in. So access to those technologies, the sovereign who is in government of India has to come in. Final 2 points, Steve, and then over to you. A lot of the people are saying, the bankers are saying, we do not understand the performance risk of the electrolyzers. So there's a new financial product coming, which sits on the balance sheet of the electrolyzer manufacturer, and that instrument is liquidated damages insurance. Your standard performance guarantees and warranties will not cut it, right? The developer and the bankers want to know, if you're promising 100 kilograms of hydrogen, will you deliver 100 kilograms of hydrogen? And if the production is less than that, no ifs and buts, guys, you have to insure everyone, because it will take forever to educate all the bankers and investors in the room. So insurance companies are stepping up and creating a special product. Final point is finding Nemo moment. In the financial world, interest rates have gone up globally, the global macro. US 10-year money, UK, Europe 10-year money is at 5.5%, which means renewable assets, unless you bring Inflation Reduction Act kind of instrument, renewable projects are not attractive because they're just yielding 5-6% in UK and Europe. The UK ran a wind auction, not a single bidder, right? UK is #1 leading country in the world on offshore wind, not one bid. The bidders are saying, unless the government increases the cost of power by 80%, we're not bidding. And that's not going to happen, which means markets like India, who are offering 9, 10, 11, 12% yield, will become extremely attractive. But this window will not last forever. If interest rates start to taper off, again, the money will rush. So this is the finding Nemo moment, when there are global tailwinds, grab them with both hands. So not 3.5, but
at this stage you've been cut there. Other security details. But very, very interesting what you say about the advantage India has. And I'm sure that if the Indian head of state was in the lift with you, he would be very happy to hear that. So on that note, I'd like to close this panel. I'd like to thank you all for your thoughts. Unless somebody has a question from the floor, we can take 2. Oh, the boss wants a question. Please go ahead, sir.
If Steve can accommodate.
Yeah, you can identify yourself and your organization, please, sir.
Okay, this is from the host itself. My question is to all the 3 gentlemen on the right side, on the stage left side. First is to GHO. The point is, I think this aspect of the green hydrogen thing, we have not deliberated much, especially the risk factor, the interest factor, and how to open up the funding. So that is one use case that I think we should all, I would request ADB also to take it up in a bigger scale, because if it is going to be domestic funding, or is it going to be foreign funding, or is it going to be institutionalized banks, and at what rates they are going to open up. We should also think about multilateral organizations who are offering and at what rates, and what is the tune of that. That is one thing. And sorry, the second thing, which is on to the 2 gentlemen on the right side, is the use cases. I think it's time that the use cases of hydrogen, whether it's electron or molecule, or it's going to be steel industry or chemical industry, that needs to be obligated in terms of policy, in which Gujarat itself is planning on it. But the use case scenario, we need to make certain kind of obligations all around the country, I would wish to know if anything, any suggestions are there from the people who's pushing that. So that's from my side.
Yeah, thank you. Thank you for bringing up. And that was my opening point that whilst the engineering community and policymakers are active, please don't think the bankers aren't active. Right? And it's taken us a while to get to that point so that we can start to identify and price risk. Pricing risk is very, very important because if you cannot price risk, you cannot insure risk. If you can't insure risk, you don't know what the cost of capital would be, right? So we finally reached that point, and I'm delighted to tell you that on 28th and 29th of November with MNRE and the G20 Secretariat, we're doing a climate and energy transition finance event in Delhi. All of you are welcome. And we'll be releasing this library of instruments. We'll be releasing the structures that Government of India has already started to think about. And one such recommendation is that whilst the sovereign will work at an aggregate level, the states have to also come up with their own market makers, right? Because there are lots of consumption that you would have locally. And once you establish a market maker, and you can play that function, right? Your organization can play that function. Once you establish that market maker, you give a very strong signal to investors globally. Very, very strong signal that, hey, everywhere else, the cost of hydrogen is still evolving. But in here in Gujarat, there is a market maker that's willing to pay X, right? And projects will start coming in immediately, right? Not just announcing of projects, people will start moving. So market making is very important.
Something could be explored, say through the GIFT City route or something which is already existing, because it's closely to the International Financial Center. I would request you to, if you could kindly consider at the national level, if something could be pushed through that route, because it is anyway a sovereign route, which is backed by the government of Gujarat.
Happy to discuss that offline.
Yeah, on the question of mandates, right? Now each state will have a different propensity of how much they can do, depending on the usage, depending on the demand, depending on how much supply can be given to state, right? Also availability of RE, because that's going to be the backbone of everything. Having said that, I think there are 4 segments at least that come to mind where a mandate can be ramped up over the years, maybe in the next 15 to 20 years. And again, you may call them hard to abate sectors, but then there are really no easy sectors here when we're talking about green hydrogen, right? Because it's not something that's prevalent today. But those sectors would probably be refineries, fertilizers, city gas distribution, steel, or anything that requires heat, right? So now, specifically in case of Gujarat or states like Gujarat, where there are ecosystems, there is infrastructure in Gujarat, and there's likely to be better infrastructure in the future, and I'm sure the government is doing its bit on that. And there, hydrogen hubs, hydrogen valleys will play a very significant role. And I think that's where I recommend. I definitely appreciate the steps that the government has taken here. We are a part of that too. We have already signed up an MOU with Deen Dayal Port in Kandla for a green hydrogen hub system, and we're working toward that. I think such efforts, such initiatives, elsewhere in other states in the country will also do wonders.
Thank you, Sanmit. Once again, there is very little to add, sir. Having said that, earlier I was pessimistic, but now I'll be very optimistic about it. We have also sanctioned a couple of green hydrogen based projects today, and we are not the only lenders in India. So basically, it shows that there is confidence in the technology per se, in the product per se, and how exactly it can work. And of course, this will increase as Sanmit rightly puts. We have to start taking the steps from fork to note. The problem today is that this is not really happening at scale. This is happening in the pockets of opportunity. This pockets of opportunity is where some of the mandates have already gone in, either by a route of CBEM or whatever that particular route would be. But if that new or emerging usage is the one where these pockets of opportunities is existing, the existing utilization of hydrogen is still not able to categorize or move into the adoption of hydrogen. But it's the emerging use cases, which because of the business reasons are going towards that. With this PLI or even contract for difference, any such kind of scheme which can play a market making role, or any institution which can give that kind of a market making rule, we will be on the cusp of starting with a large project, which will then open up the market for the existing use cases to pick up. But the newer use cases, once again, these newer use cases are not coming on its own. It's coming because of the necessity around it. And that necessity has already been created around the world. We just have to adopt it and move towards that. As Sanmay has already listed down all the segments, there is nothing much to add from my side.
There's a question from the floor. We have time for one more. Oh, I'm sorry, this is please ask your question, sir.
Hi, this is Rajmohan from SR, and this question is to Mr. Arnav. And do you think that green chemicals will fetch a premium as the current price level itself it is on the higher side?
Yeah, so I think that's a good question. And again, it would be difficult for me to speak on behalf of the entire ecosystem. Each organization will have to look at its own design and cost. So let's look at methanol, right? So methanol stoichiometrically is saying it's CH3OH. So for a ton of methanol, you will need about 125 kilograms of hydrogen. And there lies the secret. So the cheaper your green hydrogen is, the cheaper will be your green chemical eventually, right? So then we walk back towards it. Then, of course, for you to get that green hydrogen, you would then need green or round-the-clock RE power. So the cheaper your RE power is, the cheaper your green chemical will be eventually, right? So at a ballpark level, if we can get green hydrogen at $2 or $2.50, everything will make sense. At $3, probably somewhere there, maybe not, right? There or thereabout. But yeah, so that's the aim. Now, $1, of course it will. Now, when you add that to the other mitigating mechanisms, such as, if you are able to take advantage of, let's say, EU ETS scheme, the carbon trading schemes, then it starts making more sense. But again, I think it's still a little early to talk in general about, where the market is or how it's going to grow, but it's worth looking at. We're definitely looking at that. We're trying to create the pathway that will make it commercially possible for us. Thank you.
In fact, sorry, and the question is slightly, I am taking it to deep, it's not on, I'm not talking mainly on the derivative, right? I am talking about the chemicals coming out of this methanol. For example, it is acetic acid or even this, caustic soda or chlorine. So I'm talking about that specifically because if it is a green ammonia, gray ammonia, it is already slightly, it is not still matured, still at least in the, establishment stage. But I'm talking about the pure, chemicals like caustic soda, this, acetic acid, right?
No, so commodities, when it comes to the general principle is that the commodities will have its own market ups and downs. With green hydrogen, you don't want that. And that's where the basic mismatch happens, right? I don't want to go into the price points per se, because that can vary, but then there's a basic mismatch between how a commodity market behaves versus how hydrogen, which is very intrinsically linked to the infra market through the RE side, behaves, right? So you want your hydrogen to be at a fixed cost so that then you can go and build a product which can compete with your commodities. But let's take this offline because it's not something that I'd probably be able to discuss here. Yeah.
Okay, so thank you very much for that. We're going to just have a photograph and then there'll be a closing vote of thanks. So lunch is very soon. So on that note, thank you very much, gentlemen, for your panel. And thank you to Yuji, who was online, who was very kind, and for Bratton, who was online as well.
Yeah, thank you, the esteemed panelists, and great thanks to Yuji Park and Bratton Roy, who has joined us virtually. And as a customary thing, I would like to do a panelist a vote of gratitude, and I'll call upon Himanshu Patel to give a token of appreciation to Mr. Arnav Shah, VP Sales, Glencoe Group,
Thank you, sir. I call upon Kirit Travel to give a token of appreciation to Mr. Sanmit Ahuja, GHO. Next, I call upon Jasmine Patel to give a token of gratitude to Mr. Abhinav Sultania, energy specialist, ADB. I call upon Mr. Dipesh Patel for a token of gratitude to be offered to Mr. Mudit Jain, Tata Capital. Thank you so much. So this is the final of our technical session. I hand over the mic to Stephen Peters for the vote of thanks, customary. Oh yeah, sorry, a group photo obviously before that. Can we have a group photo, please?
Okay, thank you, everyone.
Thank you.
Thanks, I'll grab that. So everyone, thank you for being so patient and going so long with us without a break or a coffee. So I'll just be very, very brief. I'll just do a quick wrap up. One of the things we've heard today is that there's a little bit of uncertainty, but there's a lot of work that's going on in green hydrogen. And if you can break down what hydrogen, the areas where hydrogen's being broken into working on, there's three areas. There's the large commodity hydrogen as a commodity type projects, which are some of the focus in Gujarat. Then there are the hard to abate sector projects where you're looking at putting hydrogen as a raft of measures to decarbonize large industry like steel, cement, fertilizer, aviation, chemicals, glass, marine transport. And then the final one is looking at small distributed energy. And I'll give you a great example of Gujarat. Just outside Vadodara, there is a company that has been going for the last 40 years that makes gasifiers, turning agricultural produce into hydrogen and carbon dioxide. Those types of technologies could be revolutionary in terms of the small energy suppliers of hydrogen. So that means that there is also potentially a market for hydrogen in a trailer and that type of innovation. That is indigenous Indian innovation. That's already here. It's already happening now. So I'm really glad to hear about the focus on bringing stacks into the location. We have about 100 people online from around the region. And I think they'll be sitting there listening to this conversation thinking, we got an enormous number of people of very high caliber to sit and talk to us for 2 hours or 3 hours. The panel we had today the panels and the speakers were fantastic. I'm not used to having very high level people sit in a panel to talk for 5 minutes. So I thank all of them. And I also thank those people who asked to be on the panel and couldn't. And again, there are a lot of very high level people in that circumstance as well. I think that's a testament to the interest that people have in Gujarat because Gujarat's driving this forward. I'd like to thank the team that put this together. I'd like to thank our colleagues from GPCL, notably Mr. Mistry, who was very kind and fielded a lot of queries and was very supportive. I'd like to thank the audiovisual team and everybody else who's arranged the event. I'd also like to single out my colleague, Abhinav Sultania, who's done a spectacular job. And in fact, I got a lot of airtime here, but he did 90% of the work in organising this event. So well done, mate. Well, good job. I'd also like to talk about my friend who's sitting in the front row, who gets to bully me and tell me that I should ask questions, and that's okay because he's my friend. You do that. I'm hoping very much that we can do more work with Gujarat. Mr. Moot talked about how Gujarat was the centre of the collapse of the price in solar. That was 15 years ago, 10 years ago. Well, it's a good place to probably try and do that in 8 years ago. Okay. So this is probably a good place to try that again. If it's worked here, let's try and do it again on hydrogen. So there are these three areas we can look at. We shouldn't focus entirely on one. Sunmit talked about a range of the measures that are required. So I think we have a lot of opportunity. I would really like to thank GPCL and the government of Gujarat, and I look forward to having you attend other ADB events in the hydrogen space that we will be doing. And I've got to give Sunmit a plug that the Green Hydrogen Organisation has been doing a number of consultations, and they'll be happy to speak to you. And I also look forward to seeing you at Vibrant Gujarat in the 10th to the 12th of January, where there will be sessions on green hydrogen and RE and battery storage and a range of measures to reduce energy use and make resilient the energy economy more resilient. I'd also like to thank those people online from around the region who've joined us and asked us questions. So on that note, declare today closed. Thank you. Again, please come and have some lunch. It's just outside. Thank you, everyone.